All right. How's everyone doing? How is everyone doing? All right. So I'm a little late, later than planned, like half hour late. My apologies. I'll work on that. I'll work on that. I do try. It's weird. In real life, I stream, or I'm a very prompt person. I'm always on time to everything. I hate being late. So yeah, that's a little weird for me. It's a little weird for me. I think part of it is I try to stream to you guys as much as I can actually stream. And so I'm literally squeezing, like, I'm always very close to like other obligations. And so yeah. Anyways, doesn't matter. Let me get my streams up to monitor. Make sure everything looks good. And then we'll get into the looks good. Looking good, looking good. It does indeed, doesn't it? It does indeed. Thank you for that. Title's been updated to reflect. So today we're going to start a little special. I know that we didn't get our emergency news section in the middle of the week. I was just very busy again. I apologize about that. This was supposed to happen half an hour earlier than it was today. I am trying. But so I wanted to talk to you guys today about what happened with Redis. We're going to cover Redis's posts. Then we're going to move on from Redis's post to what this means to you. And then we're going to talk about one other thing that we talked about earlier in the week. And I just want to do a follow-up on it because I know more at this point. All right. So let's start with the post from Redis. And you know what? I want to make something clear. A change of license doesn't affect you now. It affects future versions. So if you have something that's working now, there is no panic button. There's no panic button that you need to press or you need to slam down. Now, what will become the biggest issue is like security updates and things like that and vulnerabilities that are found, because those things are found in these things and you're just not going to get new updates because the new updates are under the new license. So there is reason to be moving. I'm not saying to just, be lackadaisical, but there's also nothing to do right now, today. All right. So let's get into it. Let's talk about it. Let's talk about the impact afterwards and what you might be able to do. All right. So let's do this. Boom. All right. Future Redis releases will continue to offer. Let me make that a little bit bigger. It's easier to read. Will continue to offer free and permissive use of the source code under the dual RSAL v2. If that's surprising to you, we will cover what the RSAL v2 and the SSPL v1 licenses. These releases will combine advanced data types and processing engines previously not available in Redis Stack. Now, I'm actually kind of a fan of the SSPL. Now, I'm not a fan of rug pulls or, telling your community one thing and then changing. Obviously, there's issues there. But in the grand scheme of things, it's not an open source license, but I actually am not I don't have a big problem with this license. So yes. Anyways, let's what a deal, isn't it? Sorry. All right. Sorry for that distraction. Let's move on. All right. So, but the SSPL is actually very well known. So this is a very well known. This was created a while ago for MongoDB. Basically, it's the same as it's very, very close to the Apache license, except that it basically says you can't use it if you want to provide MongoDB as a service. That's its thing. So you can use it on your systems and whatnot to host your things. It's actually probably easier to use than the AGPL v2. It's probably easier to use in your application than that for an enterprise. Anyways, so yeah, let's move on though. This is changing their license though after 15 years. Beginning today, all future versions of Redis will be released with a source available license. Starting with Redis 7.4, Redis will be dual licensed under the Redis source available license. That's what this RSAL v2 is, and the server side SSPL v1. Consequently, Redis will no longer be distributed under the 3-clause Berkeley software distribution. From day one, Redis has provided a foundation of performance and simplicity for the application and data infrastructure that power the modern internet. Now, 15 years later, we're proud to serve millions of developers across the globe by supporting real-time applications the world depends on every day. We have already implemented dual licensing on our advanced Redis modules under the Redis Stack distribution, which has been well received by the community. In fact, more than 50% of Redis.io downloads from Redis 6 and beyond come from Redis Stack. I actually wish that people would stop focusing on downloads. I actually really wish that we would stop using this as a metric. Like it has some useful data, but it's also can be very misleading. Like this one right here. Maybe there are Kubernetes workloads that download a new image every day or something like that. It could be used actually less. So it basically, depending on the type of thing, it doesn't mean how many people are actually running it. And I get it that there's not as many, there's not many metrics to use, but just understand this isn't a really great metrics. Yeah. From Redis 6 and beyond, come from Redis. All right. We now believe that extending this license to Redis itself will enable us to continue to evolve the most holistic set of data models, processing engines, and developer capabilities for our users. That's not true. I mean, I don't think they actually believe this. Is maybe more of the statement that I'm going to say. I don't think that they believe this is the reason. The new source available licenses allow us to sustainably move permissive use of our source code We're leading Redis into the next phase of development as a real-time data platform with a unified. You know what? I wonder who came up with this real-time data platform. I wonder who coined that phrase. I wonder what software company coined that phrase. I wonder if it wasn't Redis and it was another company. I'm a little salty about that, probably. With a unified set of clients, tools, and core Redis offerings, the Redis source code will continue to be freely available to developers, customers, and partners through the Redis Community Edition. Future Redis source available releases will unify core Redis with Redis Stack, including search, JSON, vector. So there's actually some stuff coming to source available with this. If you're interested in learning from the code. And time series data modules in one free, easy-to-use package as downloadable software. This will allow anyone easily to use Redis, blah, 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 advertisement. The success of Redis has created a unique set of challenges. Redis has been sponsoring the bulk of development alongside a dynamic community of developers eager to contribute. This is probably what gets hurt the most. It's not your enterprise customers that are already paying you. It is not the people that don't care about licenses and are going to use your stuff, whether it was source available or they had AGPL v2. It's not those people that are going to get hurt by this. The people most hurt by a source available license are the engineers that donated their time to be part of your community that you're consuming their work, and these are the people that are getting hurt. These are this dynamic community of developers eager to contribute. This one. All right. However, the majority of Redis's commercial sales are channeled through the largest cloud service providers who this is an easy word, but let me try that one again. The majority of Redis commercial sales are channeled through the largest cloud service providers who commoditize. Can't do the word. Redis investments and its open source community. Despite its efforts to support a community-led government and our desire to maintain a BSD license, delivering multiple software distributions simultaneously across. So basically, Redis was open core effectively, where the core Redis thing was open, and then you had other things that they added on top. This is a pretty standard way of monetizing. Optimized for different on-premise and cloud platforms. Is at odds with our ability to drive Redis successfully into the future. Maintaining open core has a cost. Maintaining open core has a cost, and you're never going to have a community-led governance model when you have real business needs that are driving it. So this was a whimsical desire, and I don't believe that they believe this either. Because what happens is you then are at odds. Let's say business X that drives 10% of your revenue decides that it needs X feature, and the community says, we don't care about that, and we don't actually want it because it's going to slow down Redis for us. I don't know. I'm making a hypothetical here. Then you're now at odds. And the thing is, that business need is going to win. So you're never going to have a community-led governance model. They were either, again, I think that this is a lot of writing to make people feel good. And so they're saying keywords here, but I don't like it when people aren't direct with what and why. This was never a goal. Under the new license, cloud service providers hosting Redis offering will no longer be permitted to use the source code of Redis free of charge. For example, cloud service. Like any open source stuff that I make that's even purely open source isn't community led. I take input from you guys, sure. And I guess the community has. But like, yeah, the NullDB, it's open source. I'm not making it community led. It's there for our education, and I have specific plans of steps and things to do for it. You don't have to make every open source project. Like, I'm not saying it as a bad thing. You don't have to make every open source project be community led and like it be a bad thing if it's not. It's okay. It can be what it is. It's good to have community led too. It's absolutely good to have community led too. I'm not opposed to it. I'm just saying you don't have to feel shoehorned into making it that way. All right. Under the new license, cloud service providers hosting Redis offerings will no longer be permitted to use the source code of Redis free of charge. For example, cloud service providers will be able to deliver Redis 7.4 only after agreeing to license terms with Redis, the maintainers of the Redis code. These agreements will underpin support of existing integrated solutions and provide full access to the forthcoming Redis innovations. All right. So if you're going to do this, and you have people that have been development, like you stated up here, I forget where. If you're going to do this, I think a portion of this, the revenue you make from this, that caused the thing that you changed that for, should go to those dynamic developers that have given you code for the things you're now selling. It doesn't have to be a lot. 5%. 5% should go to those people. They should be able to sign up and get a portion of it. We look forward to continuing our collaborative work to support developers in the latest data storage and management innovations. Blah, blah, blah. In practice, nothing changes for the Redis developer community, who will continue to enjoy the permissive licensing under the dual license. Like I said, SSPL is not the end of the world, is not the worst. Our new licensing approach strikes a balance between making Redis source code broadly available, supporting the developer community in middle iterations. Blah, blah, blah. A lot of marketing words. Let's go on. All right. So we know the server side. We'll pull this one up and we'll talk about this one a little bit. So that's what happened. So we went from the Berkeley software distribution, the BSD, to, and now be cognizant. Before this, we're just talking about the core. They've done this for a little while. Absolutely. The server-side public license is not open source. 100%. It's not. The OCI does not recognize it as open source because it limits you. Like, and they come down here and admit exactly what it does. Our newest licensing approach strikes the balance between making Reddit. Not there. In practice, nothing changes for Redis developer community, who will continue to. So basically, you as a developer, you as somebody that's hosting Redis internally, technically nothing has to change. What the SSPL does is, if the Null Cloud wanted to provide Redis as a service, we would have to pay Redis. We couldn't host it and provide Redis as a service. We would have to not do that. Or we would have to pay Redis. So the SSPL basically is a very permissive license with a single restriction. And why the SSPL doesn't fall under open source is because the open source requires that you can't target a group that says you can't use it. And that's what the SSPL does. It just changes the wording to say you cannot provide it as a service. Other than that, you can use our software. And this has been adopted by MongoDB for a while. We can look that up. When did MongoDB start SSPL? 2018. Has it only been that long? I thought it was longer, but yeah. Why does the Oracle Cloud get to decide what? It's a conspiracy. It's a conspiracy. Oracle Cloud is 100% behind the Okay. So Oracle Cloud, I have commented that the Oracle Cloud naming convention was a bad name because there's naming conflicts out there. Now, while I don't think that you need to go out and chase this open source definition if you don't want to, there is a group called the Open Source Initiative. The Open Source Initiative is the group that technically has the hubris to say they define what open source is. Now, again, open source, if you're wanting a technical term, this is what people point to. So that's the Open Source Initiative, the OSI, you could say, and they list a bunch of rules for you to follow. Redis is open source. So Redis is now a source available, and it's under the SSPL. We can talk about the SSPL, what it restricts, what it doesn't restrict. It's the same as MongoDB. Now there is this new Redis, Redis source available license, which is different. I actually don't understand why they desire to have a dual licensing. Why not just cover everything under the SSPL? So I haven't dug through this because I honestly didn't know it existed until until like a day ago, and I haven't had the time to go over it. I'm also not I'm not a lawyer. I'm not recommending what you should do. Just giving you what's happening. The SSPL is a pretty well-known license at this time. You know, it's been out for 5 years. Yeah. All right. So, what does this mean to you? Well, if you're not able to use the SSPL, it means you got to change. So, if your company is able to suffer the SSPL, if whatever you're doing with Redis falls in line with the SSPL, the thing is you can probably continue using Redis. Okay? So that's the first thing to check. Check with your legal team if you're able to continue using the SSPL in the ways that you are. Again, the SSPL targets people that are doing it as a service. So if you're not providing Redis as a service, I believe that there's probably a decent chance that you're capable of continuing on. Again, not legal advice, but I do believe that there are probably a large majority of people that fall within that. Now, there's going to be some businesses that say they don't want the SSPL because they have an approved license stack, and that's not part of the license stack. So even if it would be okay, there's people that just won't accept it. The AGPL falls under the same thing. There's companies that just don't want to suffer the risks of it. And because of that, they'll just say no anyways. So you really do need to check, and there's probably a larger group of people that's going to happen to than that they actually fall afoul of the SSPL. This will probably lead to a price increase for the cloud offerings as well. Yes. Russell, thank you so much for subscribing. I really appreciate it. That's amazing. We need a special sound for it. I super appreciate it. Thank you. All right, now people were asking for what my alternatives were. And I kept this to pure in memory. So if you can't continue on with Redis, if you can't continue doing what you're doing and you want an alternative, then there are some. There are some pure open source. There are some. There's one that is kind of a dual stack. Now I am only posting my favorite. There are plenty. We could even talk memcached if you want. That's like an old school one. Memcached. So there are a lot of options out there. You know, I'm going to put memcached because it was maybe one of the first ones. It's been out there. So anyways, so there are a ton of options. So I'm not listing every in-memory key value store that exists. I'm talking just some options that are out there. One is one that I've actually been meaning to play around with, but I haven't actually, so I can't tell you if it's good in production as of, just yet. But it's been around for a little while now. But it takes some interesting takes on it. And anyways, let's get into it. Obviously, not sponsored, not asked to, but Aerospike. Aerospike has the Aerospike server, which is open source. It is an open source licensed. It says unknown, but it's under the AGPL. Anyways, yeah. So you can use this one. This is the one my company makes. Again, they didn't ask me to say this, but it can run all in memory. It does not have a Redis interface though. So what that means is you would actually have to adopt this. I do believe we have like a Redis translation layer that you can run, but then you're running a translation layer. It might make quick adoption easier, but there's always that. Does Oracle agree that it's open source? I don't know if we've, really checked with Oracle on this one, but there are. Yeah, there are. So anyways, this is a solution battle tested by enterprises. Lots of enterprises. You can go look it up. Some really big people leverage this and do quite well with it. So yeah, there's this one. One that I find very interesting is Dragonfly. This is one I haven't used in production, where as Aerospike has been leveraged in production by very large companies. And we could check on Aerospike's website to see which ones we publicly do. Dragonfly, I'm sure has been used in production by somebody. I'm not saying that it hasn't been. It's much newer. It's like a year or two old. It's much newer, but it's built on some recent things on in-memory. So it has like some more newer, later to date. It's actually way faster than Redis as far as memory store. And one of the greatest thing is it comes fully baked with a being Redis compatible out of the box. Even memcached, which I think that's kind of staggering. Although memcached is actually a very, very it's a very simple interface. Memcached is very simple. So yeah, now I haven't validated that it provides 25 times more throughput. These I would take with a grain of salt. You can always find a workload that works for your thing better than the other person's thing. So you could probably find a workload, but a lot of people have said that it's provided them much better throughput. So whether it's 25 times or not, I believe it's probably actually faster. So Dragonfly is one to check out. Like I said, I haven't used it, but I've been keeping an eye on it. It looks pretty good. It looks pretty good. Interesting here, they didn't put Aerospike against it in their testing. They didn't want to get their pants beat off them. We could do that. I don't know. Haven't tried it. So anyways, it's an in-memory data store. It looks pretty cool. I kind of want to actually try it. So this is another option. KeyDB. This is probably the most battle-tested alternative that's a pure in-memory. KeyDB is a fantastic database. It's I was going to say safe and reliable. KeyDB is great. It's also a drop-in replacement to Redis. So what I mean by that is, like, basically, as long as your Redis client, which will remain open source, they mentioned that, you can drop this in, and basically you could spin this up and then all of a sudden start pointing your servers to it, and they wouldn't know that they weren't talking to Redis anymore. So these are my recommendations. If you're trying to get away from Redis, if your company has said the SSPL offers too much risk for them and you'd like an alternative, then I would definitely check out these. So, does the community have any ones that they'd like to talk about? These were the ones that come to my mind. So KeyDB, Dragonfly, and Aerospike. There's also, of course, Memcached. I don't love Memcached, to be honest, but it's there and worth stating that it is truly battle tested. I mean, Memcached when was Memcached created? It's been used in production since before I was born, probably. And was Memcached? Okay, not that old. It's not that old, but it's pretty old. Originally written in Perl, so we know the people that wrote it were really smart. Cool. Do you guys have any recommendations? Did I miss a really popular in-memory? I'm gonna take this silence as a no. No, I didn't miss any. Yeah. What is your favorite? What one have you been using? Let's do that. What is your favorite? We could do a poll if you guys wanted to do a poll. You seem pretty silent today. Pretty silent. I almost clicked shield mode instead of a poll. All right, we're doing a poll. We're going to do a poll. Nope. I clicked the wrong button. We're going to try to do a poll if I can do it. Here we go. New poll. What is your favorite cache? All right. What is your favorite cache? We're going to do KeyDB. We're going to do Redis. We're going to do Aerospike that nobody's heard of. we're going to do that's not fair. And Dragonfly. There we go. Dragonfly. All right. So let me know what your favorite memory database is. VoltDB is an interesting one. I have not used it. VoltDB isn't a straight... There's it. I should have done a none of the above. I should have done none of it. You can't. One of those has to be it. So VoltDB is an interesting one, but it's also not seemingly publicly maintained. Like the last commit to it was like 7 months ago. But VoltDB is an interesting take. Yeah, it's not. They're not updating this. So I guess VoltDB is, but they're just not doing open source anymore. Maybe it just doesn't need it anymore and it's fully finished. That would be awesome. I have never gotten a project to that point. I think there are some smaller projects that could possibly be really close to that. Like besides like security things that might pop up, but so why I say that it was an I was hoping that like they would say what was interesting about it. I don't want this. I want VoltDB isn't a pure in-memory database like the like what you're thinking of. VoltDB takes a. I just want like your marketing. Where's their marketing? I don't remember it off the top of my head. It was kind of like ClickHouse. It was kind of like ClickHouse, where it takes a very, very unique approach to it. Yeah, it's kind of like ClickHouse. I feel. All my Hello World apps are feature complete. Well, thanks for the person that went with Aerospike. You guys got me. Never used an in-memory database. So a lot of the times they're used for caches. So when we talk about a cache, a lot of times that's an in-memory database. There are ways to avoid this other than caches. They're also used for data that's okay to be I'm not a little stale sometimes. And you can just speed up data that way. So most likely the number of active viewers on Twitch has something like this because it's stale data. We know this. We've done some tests with it, where it's not actually purely accurate. And so there's times when not purely accurate data is okay. It's either a cash or the company lives by the term YOLO. No. It's move fast and break things. I don't know why you call that YOLO, but it is called move fast and break things. It's a very good term. Very good term. It's the move fast and break things is the, I feel like that's like the corporate definition of YOLO. YOLO sounded too not businessy. So we had to come up with a new term for YOLO, which is move fast and break things. I didn't mean not purely accurate, but I meant maybe a little stale. It can sometimes be expensive to make things like for everyone to read the number of views that's happening every second. That could actually be pretty expensive if you wanted to make sure that everyone was seeing the same number. Most likely, my guess is that those views, everybody sees a little bit of a different number, even me. That would be my guess, is that we all see slightly different, and it's allowed to be a little loose like that. All right. So there's one other topic that I wanted to talk about really quickly before we get into some fun code. We're gonna open up Acceledraw here really quickly. So Sunday, we're gonna make a timeline here. There was a very public hack of a game called Apex Legends. We're going to put it here. And I warned you guys when I think I posted on Monday when I found out about it. Now, I'm going to say a hack of Apex Legends. One of the things that we're going to talk about is that it might be Apex Legends. There's a lot of things that go into this, and I've been reading up on what we know right yet. So at this point, Easy Anti-Cheat, the anti-cheat being used, has said that there's no evidence that it was them. Now, this doesn't actually mean that it's not them. It means that they looked through all their access logs and all their stuff and said, I don't see any evidence that this was happening through us. Now, this hack is maybe a remote code execution. I'm going to say maybe. I'm going to put this here. Thank you, Russell. Okay, so Easy Anti-Cheat has so far today, we still haven't gotten word from the publisher Respawn about it. Other than they are looking into it. We do know that much. And I could tell you they're looking into it. This is not a small deal to them for sure. All right. So at this point, we don't know. But one thing that we do know is that I was looking at Pirate did a stream digging into it, and he is pretty sure that the machines were compromised. So at the time of the hacks happening, whenever they got hacked back here, the machines were compromised. Now, if they got compromised through the game or not, they still don't know. Or did they get compromised because these streamers clicked the link that they shouldn't have clicked, installed something that they shouldn't have installed, or whatnot. There was evidence that the machines and systems were hacked, but they don't know whether it was through the game or not. I think Pirate thinks that there was a good chance that it's not through the game, but again, not really sure. So really, that's about where we're at with that. Should you continue playing the game or not? I don't know. I would go watch Pirate's stream. He did like a 2-hour stream. I watched that. I went through the media clippings of it. I filtered through the stuff. And that's where we're at. So I just wanted to update you guys because I know I had brought it up. I try to bring up anything that potentially affects you guys. You'll need to make your own decision whether the risk is out there or not. So I guess the big question is, what caused the initial breach of their machines? Was it a hack that happened not through the game that these people leveraged? Or was it a breach that happened because of the game? That's probably the big question that's out there. And the answer is, I don't think anybody actually knows except for the person that actually executed the attack. I don't, Monta. So the server ID thing, I think is actually I don't think the server ID thing is that big because look, they support. I'm just going to put a few up here, but they support a bunch of servers here. And if you're wanting to screw with a streamer, if you crashed all the servers, and there's hundreds of thousands of servers, if you went through a script to crash all the servers, then one, not only are you going to get a group of security professionals tracking you down right away, this is going to be bad. If you want to specifically screw with streamers, you'll want to find their server to crash it. So I don't think that this is actually as big of a deal as they were talking about, because this was when, if you actually watch it and pay attention to what's happening, the guy that was the streamer was talking about, this was when he was crashing the servers and bugging the servers and gifting them things and specifically screwing with the streamer. That means he needs to know what server the streamer is on. And if he doesn't know, he has to just join a bunch of games and try to find where this, because he was specifically screwing with the streamer. So I don't think that has anything to do with the hacks we saw on Sunday. Okay? So that was him doing something. Now, maybe they're related. Maybe the hacks use the same thing, because a lot of the times you'll see hacks that build on top of each other. Who knows? That's what we don't know. And we can't make the assumption that this server ID, I think making the assumption that this server ID is anything more than trying to find which server the streamer is on to screw with them is much of a thing. Absolutely. There could be a piece of software that they used. 100%. 100%. There could be they're big streamers. So they could be easily targeted. So that's what I'm saying. Like, we don't know what caused the initial hack. We know that their systems were compromised. Was it the game? Was it a piece of software? Was it that they had really crappy internet browsing things? So I think the biggest thing that we can say from this is possibly, and this is not me pointing the finger at them, possibly it was them clicking the link that they shouldn't have. We've talked about this. You got to be very careful when you browse the internet. And so this could have been that they were compromised from something else that they did. Very easy. It doesn't mean that it's not, though, unfortunately. Respawn has a lot of work on their hands, and that sucks. I actually feel bad for any company going through this. I feel bad for. I feel bad for their developers. I feel bad for the people that have to deal with it. Yeah. I feel bad for them. Anyways, that's the latest that I know. I just wanted to keep you guys up to date with what I knew, and he would be dumb to use it in the public eyes. I mean, it all depends on why you're doing it, I guess. If you're doing it because you think it was going to be funny and to ruin a tournament, then that's exactly how you want to do it, right? I don't I'm not gonna say I know their motive, but their motive could be just about anything, right? All right. So anyways, I wanted to just wanted to get you guys up to date with what I knew, because I know I had posted it. And yeah, have fun with that information. Easy anti-cheat is used by a lot of games. Yep. Yeah, and I want you guys to understand that when a company comes out and says that there's no evidence, it doesn't mean that it's not a new exploit on Easy Anti-Cheat. It means Easy Anti-Cheat went through all their logs and didn't see anything they found to be suspicious, which is good. It means they did their due diligence. I would say that until other places provide that as well, that, you know, there's a fairly decent hope that it's not them. It doesn't mean that it's not them, though. It just means that it's another, yeah. Oh, they said that they were, yes, they were very confident. I mean, like, most likely, Monta. Right, Russell. So that was the thing. There is evidence, and sorry if I didn't make this clear. There is evidence that points to the fact that their machines were compromised because there was a direct connection from outside that was made. So this is where, like, the remote this points to a known DigitalOcean jump box. So there was a known DigitalOcean jump box that's on a lot of lists that is a known bad actor. So on a lot of things. So this is probably a compromised box because it's used in a lot of different attacks. Now, this DigitalOcean jump box connected directly to the machine over RDP to install the software. So this would very much point to that this had been compromised previously. Now, what compromised it, we don't know. That's what I was saying, is it could have been a link. There could have been a link that was clicked. There could have been an install of something. It could have been Easy Anti-Cheat. It could have been Apex. It could have been Microsoft Teams. We don't know what this is. Right now, there are, two things: Easy Anti-Cheat and Apex, and probably Discord and whatnot, that are shared between these people. Yes. Windows. I don't know. The list probably goes on. The amount of overlapping is a massive amount. Yeah. Yeah. It's 100% DigitalOcean. I found that to be really funny. It can't be Microsoft Teams. Right. So the fact that it was compromised doesn't mean that it wasn't Apex Legends. It just means that at the point of the hack, the box was already taken over. The box was already lost at that point. So the hack that you saw on stream wasn't actually the hack that got them control of the machine. It's what they did with it after they already had control of the machine. So, anyways. But yeah, it was 100% DigitalOcean, which was amazing. I'm not gonna speculate. I don't do any of this stuff. I've been on the receive like I've done some. I do inside data center security stuff some, but not really. I like to be up on understanding how to prevent stuff like this, but I'm not red team, blue team. There's a lot of better experts. All I was doing was talking about what I had brought up with the latest. I'm not going to dig into this because that's outside my purview. I'd like to make it better. I'd like to understand better. I'd like to do more with that. When I get the time, I will. Phishing scam. Russell, if phishing scam, 100%. They could have just been phished by an email. It's so much easier than finding a 0 day. Yeah. 0 days are hard. The other thing is 0 days are actually hard to track down. So unless if they're constantly being exploited, they're actually difficult to track down. So if you have a 0 day that's like actively being exploited and you see the network pattern, you can capture that network pattern and you can kind of try to understand how they're hitting your system. But in this case, we don't know of it happening any other times, which means it could be a 0 day exploit. But if they're not using it, you're kind of guessing at some of the things. And now I'm sure that they're going through their server logs and checking their access patterns during those times because they have timestamps now. So Apex actually has a huge thing now. They have exact times because of those streams for access patterns for anything that was happening. But the problem comes if the machines were already hacked. The hack happened some other time. So it doesn't actually give them exact times if the attacks didn't require any EA systems at that point. And again, could have never needed EA systems. Could be literally anything else on those machines. A phishing scam, yeah. Oh. Copilot would probably give you a 0 day. Let's see. I don't want to show off the Rust lesson for today. Let's see. Let's see how it's doing. Let's see if it does it. All right. Can you find a 0 day in this code for me, please? It's just blocked. It's just blocked. It won't do it for you. Now, I can theorize why. They don't want people using this to find attack vectors. But it also means that you can't use it to find defense vectors either. That's dumb. I guess they don't have any way to know whether I'm using it for attacking or defending. Yeah, they have a sanitize. Sure. So what? We need to ask it in ASCII art? Is that what you're saying? We need to ask it in ASCII art? Yeah. That makes sense. The AI is expensive. You wouldn't want it to do off-topic things. You wouldn't want people to use it as ChatGPT here. That makes sense. This is such a canned response. Oh well. So I'm not a fan of keeping in this specifically. I'm torn. I'm not a fan of keeping things secret. So I guess my thing is if Copilot would come up with these things, they should just automatically be public. Because the thing is, like, if a hacker can use ANSI art to make it give that information anyways, then you're really just keeping it to really motivated people, and not the person that just wants to defend their application. No AI is going to replace me. I type too poorly. All right. I should have opened this. I need to be opening this so we can keep all of our ideas and topics and stuff on here whenever we have one. All right. Cool. Let's we have roughly an hour and 10 minutes. next ad break, I'm going to make a little bit longer, and I'm going to go make a cup of coffee. And what do we want to do for the next hour, 10 minutes before we do the Rust and the Kubernetes? Although, so I found out some people that are joining the Kubernetes don't know how to do containers. So the very first intro to Kubernetes is going to be a very practical guide to creating your first container, because there are people joining that don't know how to do that. So it's going to be pretty simple. We're probably only going to spend about 15 minutes on it. Yeah, it should be fast and easy. We're going to make a container. We're actually going to make a container with our Rust code. You don't have to do the Rust to follow along. It's just going to be showing your own code and how to do that really quickly and easily. And yeah. So macros, we're not to macros yet. I actually do think ModProg is going to help me with the macros. I got to learn macros. We'll do macros. We'll do macros. I have to do macros first. I got to learn macros. I've avoided doing macros. I mean, I love using macros, but I have not done them myself at all. One second. Sorry, the argument going on over there. Okay. Let's see. Let's okay, so topics for any of our live learning that we want to do, let's keep them flowing. I know that we had a good flow last week going, and I love it. We are going to be doing traceability in our Rust as well. So in our Rust here, we're going to be doing traceability. All of this is public, by the way. All of our live learning, there is a Git repo for this. So you're more than welcome to go check that repo out. And you know what? I'll post it in the Discord, or the Discord in chat. So there you go. We're going to be doing some distributed systems in the future. We're going to be doing some machine learning in the future. We're doing Rust and Kubernetes right now. So yeah, but we're also keeping topics for these. So if you have a topic that you'd really like to cover that could help you, let's put it in there to do. Yeah. All right. So let's see. We could do this for a little bit. Or we can look at Twitch alerts. What would you guys like to do? A little bit of Rust? We only have an hour. Maybe not enough time to get into Eddington, honestly. So maybe we just dig into Twitch alerts a little bit. Because we put in a timer and it doesn't seem to work. It doesn't seem to work. I'm restarting it every single Twitch stream at this point, at the beginning of the stream, which is kind of annoying. It's fine, but it's kind of annoying as well. So let's see if we can't see what's going on there. Let's see if we can't see what we can't see. Let's try 0 day. It's not publicly exposed to the internet because you probably could 0 day it. The null cloud dev environment. I need to actually get this formally written up. I'd like to provide an environment that you guys can try hacking ethically. Because I think it would be fun. I think it would be fun. You really hope that doesn't work? Oh, we should go check. So the one that watches chat right now only displays it. Like it will display it, but that's all that it does with it. I do want to do commands, and that's a really good one that we should sanitize any command that's given. I'm about to get people in chat. Sweet. Actually, let's update the titles. I don't generally do that in the middle. 1 second. Sorry about that. Manual raid. Oh, manual raids are the best. Manual raids are the best. All right, let me update my titles because we're just gonna do a little bit of Rust for right now. We're done with the null news. A little Rust. All right. All right. Let's go on with this. So I don't know what is going on, but Twitch stops communicating with us every once in a while. And we put in this stuff to basically keep alive. Basically, so Twitch, let's actually pull up the logs. We can watch the logs here. Let's get some music since we're not doing anything important. It's a little loud. All right. So you can see that we're basically getting this heartbeat every... it's actually every 10 seconds. We can watch it. It's every 10 seconds. Yeah. 36, 46, 26. They actually do a really good job of every 10 seconds. Like, surprisingly good. Because I want you guys to notice down here, this is the seconds. This is tenths, hundredths of a second. Thousandths of a second. We're talking about to the thousandths of a second, to the 10,000ths of a second. That's pretty good. That's pretty good for something over internet. It's pretty good. All right. But beyond that, Wait, did I screw up my name in this code? Did I screw up my name in this code? Oh. Oh, I see. I got it. I got it. Just changing Mark. I got. Sorry, I thought you were saying I screwed up my name somewhere, which is not the first time that that's happened. All right, so we're getting a heartbeat, and we tried to do this keep alive. We tried to do the keep alive and go down that path, but it seems to not be working. It's not working because it's still behaving the exact same way. And the weird part is we put some logs in there to try to capture why this terrifies me that this is in here. 1 second. Delete as this is wrong, but is how it still works for right now. Good job, Past Merrick. Good job, Past Merrick. So I guess it's still wrong because I haven't changed it. I haven't touched it. So it's still wrong. We're gonna leave it. So where is our okay, here's our run. Okay, so we don't get any of these messages. Oh, I guess we're probably not running with Warren, are we? That's probably the issue. Oh, no, we are. We're getting info. We're getting info, so we should get Warren. You know, like, I'm almost half worried that it's like the WebSocket deadlocks or something. Like, it's single-threaded, though, so it shouldn't. Like, it's a single-threaded thing, so, like, that shouldn't be the case. That's kind of half of my worry, though, because, like, it just goes radio silence. It just goes pure radio silence. Like, when it stops, it stops. We don't get any of these tracing messages. Nothing. So let's walk through this. We're doing a Tokyo select with an else statement. So basically we try to select a new message from the WebSocket, and if we get a new message, we deal with the message. And we just call this process message. That's all that goes on here. And in here, we basically keep alive updated. Else, if there is no message, we basically check the keep alive. We check the keep alive to see if it's been more than 30 seconds since we've gotten a message. Actually, really honestly, now that I'm looking at this, we shouldn't do the keep alive here. Basically, if we get any message, I think I was trying to say any valid message. I was trying to say any valid message you update the keep alive, but isn't any message valid, I guess? Like if they're actually sending parsable data, it's probably all valid. But we can wait, hang on. Is that an option of a message? This here? This is an option of a message. And then this is just the message, right? Because we're unwrapping it here. This message here is just seeing if it's an error message or a sum message. So this is a result here, right? So if the result is an error with the like handshake, the protocol, we restart. This we've tested because we were shutting down the server, which caused a protocol error, and restarting the error, and it would reconnect. So this we kind of know works, which tests this process failure. Line 65. Right. Okay. So this is a result. This is a result. We first match on the message. So this match here is unwrapping the result. Okay. After that, so on this, if it's an error, we set it to none. Otherwise, we set it to some with a message. Down here, we unwrap whatever this returned. If it was an error, we don't do anything with it. If there is some message that we wrapped here, we do it. This was just to check if there's a WebSocket protocol error. I am shadowing, and shadowing is bad. So let's change that. Shadowing is bad. I don't like shadowing, and so we shouldn't do this. Let's fix that right now. This shouldn't be message. Let's call this well, I mean, that's why shadowing is bad, is it causes people to read things improperly. So like, no, fully my bad. And I've noticed this. My code quality while streaming is poor, and I want to stop that. I want to stop that. I want to write a little bit better on stream. I get flustered sometimes while coding, and I just leave stuff that works but's bad, and I'm trying to stop that. I'm getting more comfortable streaming code, so hopefully I can write a little bit better code. But now I need to come up with two names. I know. This is why I do it, because I'm like, dang it. I said I'm going to fix this, and I don't know what I'm going to call this stupid thing, and it's so trivial. Okay, so we're going to call it M because I'm a Go developer. No, I'm just joking. I almost called it payload. You know what? As much as payload is terrible, it's better than shadowing. It's better than shadowing. I don't know what I've done to my Rust. My Rust no longer unwraps macros or is not able to actually leverage them. So like, this is getting really annoying. I need to fix. I actually need to do the Kickstart, don't I? I need to do the Kickstart. That's next after the lessons. I'm going to start. I just need to rip that Band-Aid off and grab the new Kickstart. That's what I need to do. I can put it in a separate directory so I can go back to the old. So that's what we're going to rip that Band-Aid off today, probably. Okay. This is also equally bad. It's not let payload. It's really the message, and we're wrapping it in some. Is there a better way of handling this? I feel like maybe this is just a bad way of dealing with this. I feel like instead of this, we could just do like a continue. We're in a select. Can you do a continue in a select? I don't think so. Can we just return? Can we just hard return here? Is that valid? Yeah, I think we could just return here. Let me think about this. I'm thinking that we've just made a bad way of doing this. And maybe the reason we're doing this is because this is just bad. just not good. We're wanting to check to see if we've got a WebSocket issue. And this feels weird because we're wrapping to then unwrap. Okay, this feels really bad. Okay, one. Oh gosh. This is okay. Let's fix this. Let's fix this. So let's do this. We don't want to wrap this. We're going to say, we don't want to just catch everything. Do we want to catch everything? I guess maybe. This is an okay, right? This is an okay of something. Hey, YouTube. Sorry, I don't watch YouTube chat as much. I try. What are we doing? We're killing some time before our class starts. So we do a little live learning of Rust and Kubernetes on Saturdays. That'll start in about 45 minutes. These are our Twitch alerts that we're working on right now. So sorry, YouTube. This catches alerts for Twitch. We need to expand it to YouTube eventually. We have so many things to do. Hasn't been a high priority. You guys on YouTube, let me know that it's a high priority. Mostly you guys talk about Fortnite and praising the sun. Like S-U-N, not S-O-N. Right. I either need to come up with two names or I want to just not wrap this. Let's do this. I want to experiment with this just a little bit because I'm thinking maybe we can make this cleaner and solve our problem. I'm not entirely sure. I feel like the code that's written here is weird, but it was written that way. And then this is our message, right? No information available. Oh, So that's kind of what I was thinking, Russell. That's exactly what I was kind of thinking. Is just let's just deal with it here. And I don't know how this originally worked. This is a result of unknown and error. And this is maybe why we ended up with the funky way that we were doing it, where we were doing it out here. But I feel like we shouldn't need to do that. It's very weird. I don't know. And now it doesn't know what S is unknown. But how? One second. I'm missing something. How does this work? Now it knows it's an option of message. Oh. Oh, it's not working. It's working on the result here. I see. Oh. Is Rust too difficult to learn? No, people learn it all the time. Stick around. Find out. Is it different than what you've done before? Probably. Is it more difficult than some languages? At the start. I think it's easier once you learn those things. Okay. So this is calling context on message instead of the unwrapped object. We're literally ignoring the unwrapped object. We're saying if it's not an error, then we do this with it. I now see why. Let's try this. Sorry, thinking. Oh my gosh. I'm those are on a different layer on this keyboard. So we could use just the message context here and leave this like this. And then we should be able to actually use this. I don't know why formatting is so off in here. We've run FMT on this, right? We could check. Once it's fixed. Okay, fix that. That looks better. Cargo format. I do believe this fixed some formatting, so maybe we hadn't. It's bad on me. Bad on me. Oh, that's right. Go auto formats. We haven't fixed Rust because we were waiting for the new Kickstart. So we need to do the new Kickstart anyways. Because we don't have Rust auto formatting. On save. Okay. So is this correct? Yeah. I don't like this. I actually have never done this context before, and I forget what it is. Result context. Rust result context. What is this context? I've never used this, and my Rust is not taking me to a definition. Right, I get that, but why does it give me an actual concrete type when before this we're getting an unknown, and we're not actually using anyhow? We're using IR, which is from anyhow, right? Or IR is like a branch of anyhow. Let's we can look it up though. Okay. Okay, I guess that makes sense. I just hadn't used it for forever. Okay, and I guess this is why we do this as well, which I don't love. Kind of an abuse of the system. Can we just call the with context then up here? I guess here we're checking for tungstenite errors though, which is why this would be like encoding errors, I guess. Okay. So anyways, we can still get rid of this. And then we can actually get rid of this as well. Right? And then we can get rid of this return type as well. Yeah. What's Rust? It's just a language. Okay, so this is probably cleaner then. Yeah. That gets rid of the shadowing too. This is probably not great, because if this happens, we'll fail out of our run. Probably shouldn't handle this way. Both of these. probably not the best way, but we'll leave those for right now. Okay, so what we were trying to understand is why our timeout isn't working. So, Zaid, if you'd like to learn more about Rust, stick around. In like a half an hour, we're going to do a little bit more on our very, very practical guide to Rust. So yeah, you might want to stick around for that. All right. So I think what we're going to do for this so we get this info processing message. What we're going to do here how similar is Rust to Java or Python? Not at all. In fact, I have this button here for talking about Python. Java gets a pass because it has a history of doing something cool. But Python and JavaScript, they have their own button. Yeah, we keep it PG-13 here. So we have those buttons. It's not super simple or not super similar. It's not too difficult. It's very different. It's very different. It's strongly typed. No duck typing. So for those of you in Python world, yeah. It's multi-threaded for those of you in Python world. It's very different. Very different. It has a fantastic type system. Absolutely cherishable type system. Type system is my favorite aspect of it. All right, let's see. So this is the span that we pass on. Yep. Actually, you know what I want to do? I want to do I just want to see the whole thing. All right. I think there's a way to do it in K9S. I haven't. Where it doesn't chop off the message. All right. So what we want to do here is basically, I have never seen this. I have never seen this. So when we stopped communicating, I didn't see this in our logs. And so I want to make sure that we have some logging that's going to make it into our logs. But I don't know how to do that. This should have. And this never ran. Which is weird because I feel like I'm not using Tokyo Select correctly. I have a feeling like this else isn't doing what I think it's going to do. We're running this Tokyo Select in a loop. And my assumption was that if it doesn't select this, it should select this. So we should get this a lot, right? It just should fail a lot. Because the keep alive isn't larger than this. So this It's a WebSocket, if that's what you're asking. One second. Let's am I misunderstanding Tokyo Select? Let's pull up the docs on that really quickly. All right. It waits on the first branch completes, canceling the remaining branches. Additionally, the select macro may include a single optional else branch, which evaluates if none of the other branches match their patterns. Maybe this was a bad way of dealing with this. Because honestly, this was going to thrash a little. Because Tokyo Select was supposed to select for a little while. What we really should do here is select a timer. So that timer goes off every 30 seconds to check the keep alive. That's what we really should do here. This was going to thrash because, you know, there wouldn't be a new message, so it would run else. There wouldn't be a new message, there would run else. That was the idea, because I just wanted to validate that we were catching this error. The examples don't... Oh, eagle eyes here. You're right, no comma. Is that for real? If that is the difference, I feel like that... Right, but select should cancel it, right? Right, so this would wait, right? But select is the thing that's saying, okay... Right, future highway? I mean, I could be thinking about this wrong. It doesn't? Then its docs... Well, its docs say... Additionally, the select macro may include a single optional else branch, which evaluates if none of the other branches matches their pattern. Oh, you're right. You're right. You're right. You're right. Okay. 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 We just need to call a timeout on this. You're absolutely right, because it's waiting to match. I got it. I got it. I got it. How do we... Next needs to have a timeout, right? Wait. Let's see. Add another select on future delay. As second branch with a future that returns. Oh, okay, right. So we just need to put one here. That's basically what the else is. That's exactly what I was saying. This shouldn't be an else. It should be a select that can match, right? Okay. This is what I was originally saying, and I was just trying to cheat it quickly. Which got me in trouble. Okay, so let's do that. We need to create a timeout future. Let's do that really quickly. Can we do that really quickly? Rust timeout future. I've never done that. Is there a good way to do that with Tokyo? I feel like Rust Tokyo should have this, right? Wait, you have something? We'll check that out too. I feel like Tokyo should have something. This is not timeout was the wrong word. Yes, Dirk, this is to handle the keep alive. This. Because else is going so it's a key piece of documentation. Else is going to wait for these to all of them to actually be evaluated. And this never gets evaluated because this is waiting. So this is waiting to be evaluated. So we need something that actually evaluates instead of just the else. That was a very good call out. Why isn't that part of the main message handler? This is the main message handler. You mean why isn't it part of the library? I don't know. They send it. They send the keep alive. So what I'm doing is checking the keep alive and reestablishing a connection if they don't send it to me. I'm not sending the keep alive. They're sending it. What happens is they stop sending it, but our connection doesn't break. So we still have a WebSocket connection, but no messages are coming through it. No problem, Dirk. Oh, wait, will sleep do this? Waits until the duration has elapsed, equivalent to sleep until. Oh. So can we just do... Dang it. Copilot? This is exactly what I was going to type. Copilot knew this was wrong. Let's actually do this. 1 second is way too short. I mean, we're on broad time scales. We'll run every 10 seconds to check the keep alive. We'll run every 15, 20 seconds. We'll do 10. We'll do 10. All right. We'll do 10 seconds. Every 10 seconds. We'll check if the keep alive. Because, I mean, the keep alive only runs every 10 seconds, so there's no reason to do anything more. Okay. Done. The duration from seconds is 30. I mean, this was all just copying code that we were doing, just doing it with Tokyo instead of this garbage that I wrote. Garbage. Wait, unmatched curly brace. I deleted too much. Too heavily deleted. There we go. And this is that. That's that. Okay, too many curly braces. Too many curly braces. There we go. There we go. All right. Nice. Well, this is one of the reasons I say that you have to be careful that Copilot is actually very heavily... So one of the things that they did to help with hallucinations and things like that was to actually heavily orient it around the code that you've already written. So if you wrote this wrong, though, it was just recommending my code. It was recommending the code I had already written, just with this this change. All right, is that all we need to actually do now? Actually, wait. If we don't need to set this for 10 seconds because we can sit there and wait for a message for more than 10 seconds because our keep alive is 30 seconds. So honestly, this is better. We don't even really need to have a keep alive. We could put this as 40 and just reconnect, because if this ever runs, it means that we sat here and waited for a message for more than 40 seconds, right? Nothing happened here for 40 seconds. This didn't run for 40 seconds. So we can get rid of the entire tracing and make everything more simpler, more better. We can get rid of this. We can get rid of this. We can get rid of this. And this can go here. Right. Let's see. Yeah. This is amazing. More simpler, more better. And actually, we can take this further because we don't even need this anymore at all. No, I just care about the real errors. That's not a real error. Okay, we don't have it. Wait, we have real errors still. I just deleted something. I have real errors. Process message, right? Because this should have been keeping the keep alive up to date. Yeah, that's an error. This is an error, right? It doesn't exist anymore. This doesn't exist anymore. My Rust analyzer is all screwed up for some reason. It can't handle macros anymore. I don't know why. Future highway. What do you mean by that? This is not a, just to be clear, this is not a WebSocket keep alive. This is actually a message sent by Twitch. This is a Twitch message that is sent. It has a message ID. This is a Twitch message that's sent. This is not the ping pong that a WebSocket will do. So that's what I keep saying is like the WebSocket stays alive, and I'm assuming that they do a ping pong. That's the Autobahn. Have you ever done the Autobahn test suite where they have the ping pong? That stays alive and working. Twitch just stopped sending me messages. This is actually a message type that Twitch has that they send. And then they stop sending it. Because reasons. I don't know those reasons. I'd love to know those reasons. But they stop. Because all of this is getting printed from in here. Like, it's an actual real message. Because that's this processing message. So, like, we know that it's getting a message. It's calling the info processing message. You know, this is running with each of those. So, yeah. Anyways, it's not ping pong. We love ping pong. It's a fantastic sport. It's not ping pong. All right. Let's see if this actually compiles. Let's see. We'll go with 19. We'll go with 19. Thanks, everyone. That was an interesting bug. We did two things that was good here. We simplified our keep alive, as well as we simplified our message handling, where we didn't shadow anymore. If you guys see me shadowing, we need to have a no shadowing emoji that you guys can spam. If I shadow, I should be spammed with an emoji. All right, this is actually outside this project. Let's see. So this does take this is a little biased in that it says any message from the server is a valid message to keep our keep alive going, which I think is fair. I've never seen where it gets stuck sending us one message, but like it sends us. Yeah, I've never seen this. So I think this is a valid assumption, at least for right now. We'll go with this until it bites us in the rear. Okay, so the place where this is broken is in the monolith. Don't ask me about the architecture of this. The architecture is bad, but fantastic. Bad but fantastic. That deserves its own video. Wait. Where was this? Yeah, in Maine. There we go. So the architecture is designed in a way that I would like Eddington to be able to deal with. It's designed in a way that like this would be like the demo app of how Eddington in the future could work with automatically figuring stuff out. So that being said, it's written kind of weirdly because of that. It's written kind of weirdly. Yes. and I admit that. And if this was a sane project, I would say that it was written poorly. Ah, some warnings are no problem. Sweet. Sweet goodness. All right. All right. So now we can update. What can we update? We can update our deployments and then our Twitch alert service. It's not a stateful set anymore. I need to change the stupid name of the file. You know what? Let's do that right now. Let's, instead of just saying that, I'm getting better about actually. Oh, I almost did RM. Woo! All right. Twitch alerts, stateful sets. Let's just do this right. Deployment. Twitch alerts, deployment. YAML. I don't have GitOps for this project yet. You know what? That's a good stream. We'll get GitOps going for this because we should be able to just check it in and it should just deploy automatically. You're 100% right. We have not been doing it right. Not going to make it today because we almost have class. But we will do that. Let's see. Where's image? I don't. All right. When I get back from coffee break, our Twitch alerts should function the exact same. No testing. I did not test that at all. Didn't have the time. That's how you do it. You test in production. All right. I'm going to take a quick break. I got to make a cup of coffee. I'm going to get a drink of water, and then we'll jump into making some more Rust. We're going to do a quick Rust little class. They're supposed to be short, sweet, and be very, very practical. And hopefully by the end of it in, a couple months, you'll be very comfortable producing production, Rust. Yeah, I'm learning some stuff. And then we'll do a Kubernetes one after that. We'll start very basic because I know that there's some people that don't know that. And then after that, if we have time left over, we're going to jump into my NeoVim config and starting to rewrite it from scratch from Kickstart. Everyone unfollow and follow again. No. All right. Okay, I'll be right back. Enjoy the music. Actually, I'm going to run an ad while you guys are here. That way we don't have one during the class, hopefully. That will be the hope and goal. That way I can... Yeah. All right. I'll be right back. All right. All right. I hadn't forgotten. Sorry it was so long. There was a child incident need to be taken care of. But we're all good. It's all good. I didn't forget about you guys. I didn't. Sorry it took me so long. All right. We got our Twitch alerts working. That was some good Rust. Thank you guys for helping. You guys noticed that small mistake pretty dead on, which was awesome. And the Twitch alerts are still working. They're still working because we tested in production, which is always how we do it here on Twitch. We test in production. They're working. So I'm really happy about that. All right. Let's do it. Rust 101. You know what, Russell? It's Saturday, so we don't pepper spray for school on Saturdays. That's not an admission of pepper spraying on any other day. Just on Saturdays, we don't. Not, saying any otherwise, but yes. All right, so that was Rust 101. We're going to do Rust 102. Date. That's the day. No. So that was the intro. We did the intro. We hopefully everybody at this point has a IDE set up. Hopefully they have Rust set up, and we've created a project, installed Clap, and whatnot. All right, but we're going to throw all of that away. We're going to throw it all away. Why? Because it pays to do some stuff multiple times. And one of those things is using Cargo. One of those things is using the Cargo command line tool to install a project, as well as install some dependencies. So we're going to start afresh again on purpose. So all right, so let's go ahead and get into the right directories and get into this. So today's objectives. Let's do this. New note. Day two. I can delete this one. Let's delete this one. Remember, this is all published on Git, so let me share that link really quickly. We'll get out of all of this stuff. Toggle, it's really good to see you. All right, so this is all right here. How was your stream, Toggle? It was short and sweet. That's how we like them. Oh, that's never fun. The accountant calling. Will day 3 be VC funding? No, that's day 3 of our machine learning. That's our day 3 of machine learning, Russell, when we get to there. Day 3 of a machine learning is get VC funding. Day 4 is profit. So, stay tuned for that one. Where were we going? Live learning. Rust. Code. There we go. Day 4 is profit and get an accountant. Toggle is ahead of us, yes. Toggle is ahead of us. All right. So there's a lot of experienced people in chat. I'm not always going to be able to look at chat during these lessons. There are a ton of people, whether it's Kubernetes or Rust, that know these things probably better than I do. I mean, I know that the people in chat know Rust better than I do. And Kubernetes, they probably know Rust better, or Kubernetes better than I do. Russell does for sure. Yeah, so lean on chat. If you have some questions, there's probably people that are going to... I will try to get to them as well. But yeah. All right. So, day 2, what are we going to learn? Well, we're going to revisit what we did. We're not always going to delete what we've done previously, but I did think it was important to start off fresh because we just learned a bunch of basics things, and I think that repetition is actually really good. So, last week we installed Clap. We've used Cargo for package management a little bit, as well as Cargo for creating a project. So, we're just going to do that again in a new folder. So, the goal here is to create maybe the most engineered to-do app you have ever seen. Let's turn this music off. Let's turn the music off. We're in learning mode. Most over-engineered. The engineering of this app isn't designed to be what would be good for a to-do app. Let's just get that out of there. It's to learn specific lessons along the way. Okay, so let's start a project. That would be Cargo init, and we're doing a bin again. So remember, there's binaries and libraries. We'll be making a library in the future. That's a project that's designed to be reused. Now, you can make a bin and a library in the same project. This is just basically a template. So we're going to init. You can also call new. Remember, new is going to let you create a new project as well. Init's just going to init in this folder. And we want a bin. All right, cool. And now we see that we have our code. Awesome. If you remember, Cargo Toml, this is where we're putting all of our dependencies. Let's jump over here and open up crates.io. Okay, so this is like nodes npm. It's where you go to get projects. Look at that. 60 million download. Wait. Billion downloads. Billions. All right. Let's go. We're going to open up Vim. We can use Cargo to add a project. So if we wanted to add Clap, Cargo add Clap, and we have Clap. If we cat our Cargo file, Toml, check it out. We have Clap. Cool. But we actually want to add some features. You can do that through the command line, but you can also just edit this file. I personally just end up editing the file anyways because I have to go look up the feature and everything that I want. Because I don't know them that well. So we're going to go ahead and just add some dependencies of stuff that we're going to use. So the other thing that we're going to use is Tokyo. Tokyo is going to handle our multi-threading, and we'll get into it. It's a thread execution library. That's what it's a work execution library, and it allows us to do async and await. A lot of you are going to be familiar with async and await. We're going to be leveraging async and await first, and then we can talk about like some real system process threads in the future. Okay, so there we go. We've got Tokyo. The other thing that we're going to do, so today, and this is where I meant to start. Today, we're going to create a web server. Today, we goals is to create a web server. So we should be able to specify what port we want to listen on via a command line argument. So specify the port we want to use via the command via a command line arg. We should leverage Tokyo. Use Tokyo. And then we should have just a couple basic endpoints. So we're going to have a way to basic endpoints. And those are going to be the ability to create to-dos, get to-dos, and we're going to have a very generic one that we're going to use for some testing at the very start that just allows us to get a welcome message. So these are our endpoints that we're going to make. And yeah, so this is our goals for today. We're going to make a very basic HTTP web server. Now, this isn't going into everything for TLS and whatnot. We're going to actually progress and add those types of things in the future. So if you're thinking about it, don't worry, we will. Do bring it up, because if it's a topic that you're like, oh, I want to know how to do TLS or something like that, we'll make sure to add it to our goals. We have a list of goals. Now we're keeping the 101 simple, and we're going to do a 102, 103, 202. We're going to do more advanced ones as we go. Part of it's as I learn Rust. I would say that I know Rust basics fairly well. And then there's some of the advanced things like procedural macros that I don't know well at all. And we'll learn some of those live on stream throughout the week as we're going. All right. So, and we're going to get a welcome message. We're going to use Tokyo, and honestly, I think we're just going to leverage everything from the Tokyo ecosystem that we can get. So there's actually a lot of stuff in the Tokyo ecosystem. If you go and look up Rust Tokyo, there is a lot of stuff in this, and we're actually just going to leverage it because they all play well with the execution library, Tokyo. But there's also Axum, which is the framework that we're going to leverage, which is pretty fast. There's other good ones out there, and we can talk about the breadth of it. We're going to use tracing for our tracing. Again, a pretty good one. And I mean, we're going to use Mio because it's used by Tokyo. But anyways, we're going to use these two things for our thing because they all work together fairly well. Now, again, you can use Tokyo with Axiom, which is another one, and whatnot. It doesn't mean that you can't. This is just what we're going to use. So let's look up these projects on crates.io. So we can look up Axiom right here. We can see that this is the latest. You can go here, or you can just copy this right here, copy the cargo toml snippet if that's what you know you need. But you can also look in here to see their examples. So this is just the README on their page. It's pretty awesome. And you can see that there's an example folder and whatnot. So go ahead. I'm not going to send you guys the links to this because I want you to learn to get custom to crates.io. And using it. So let's go ahead and add this. We need this. So we're going to actually just Vim and add it manually because, yeah, that's how we do stuff here. All right. And then we're going to what is it? Tracing. We're not going to install tracing just yet. We'll get to that. We have Tokyo. We actually need some stuff in here. There's another library that we're going to start leveraging, and that's SERDI. So SERDI is serialization and deserialization. I'm going to say it's probably the closest thing Rust has to a standard, standard library. There's other libraries, but SERDI is pretty good. And that's the one we're going to use. So we're going to use SERDI. SerDes. You know what? I need to stop having ChatGPT. I don't like it with this. I didn't want to show this feature derived. We already talked about it, but I was gonna broach it again. So let's find the latest version of SerDes. We just want to use the latest SerDes. SerDes here we'll just copy that. Look, then we don't even have to worry about ChatGPT. Done. Okay. And then we want SerDes JSON because we want to serialize JSON. SerDes JSON. And again, part of this is just starting to know the ecosystem. There's a bunch of things out there you can look for. There's a bunch of things. I'm just starting to familiarize you with different projects. So you might be wondering, why is there SerDes and SerDes JSON? Why is there SerDes and SerDes JSON? That feels a little weird to some people, right? Wouldn't your that's not at all what I meant to copy. That's not at all what I meant to copy. I meant to copy this. Wouldn't your serialization library handle that? And the thing is, SerDes provides a very generic way of handling things that can be implemented by a variety of things, which is actually really cool. I actually like it a lot. Which means, let's say you and I created a new format, and let's call it IMSM. And IMSM doesn't have a serialization framework. We could basically make SerDes IMSM and leverage SerDes to serialize and deserialize our custom object, which is kind of cool. It's kind of a cool concept. I like it. Let's move on. Okay, so we have these things, and now we obviously need some features. We already did this with Clap in our last one, where we needed some features from Clap that weren't in the base. So we're really going to actually need to leverage some features. So we're going to throw in these features. We'll do the version again. I forget what the latest version of Clap is. I just deleted it. It's this one right here, 453. The version equals 4.5.33. There we go. And then we do need some features. Does anybody remember what the features are? It's not YAML. All right. Well, if you guys are wondering where you can find a list of features, one thing you can do is go to the docs here, and you can go on feature flags. This is fantastic. We need the feature for parsing, which I actually forget what it's called. The macro. Is it called derive? I think it might be called derive. We'll include the feature when we get to it. I want to derive. I do know we need derive. And I thought parsing was in a different one, but maybe it's in that one. We'll find out. All right. So let's go ahead and start implementing Axum, and we'll see which features of Axum in Tokyo we need. We do need one for Tokyo that's called Tokyo Main, which is one we're going to leverage. If you go over here and look at Axum, so let's go hit Axum in the docs here. Did I uppercase it? I did. Is it lowercase? It might be. I don't know. We can go look in a second. We'll find out. All right. So if we look through the documents here, they give us a really cool example to start with. And what you'll notice here is a couple things. First, you have SerDes, deserialize, and serialize. So if we copy this in, we're going to actually notice a few errors. Let's just copy the basic thing that they've given. I hate copying code. We should just write it. Let's write it from the scratch. Let's not copy this code. Let's not copy. We were going to copy this and start editing, but in the end, we then have to delete a bunch of the stuff that they've done. So let's not do that. We will use this as a template though. So we're going to notice that this is a macro here, and this is, you know, something super powerful to use. And I actually have a YouTube video on this specifically. So if it's very confusing, you can go check out that YouTube video, but we're going to leverage that. So let's go ahead, and this is the generated hello world. We can actually run this. So let's say day 2. All right. So we can go ahead and do cargo run over here to run it, and this should print out hello world. That's all it does in there. Now, you'll notice it's actually pulling in our dependencies that we have. And your first time running will take a little while, but Rust has gotten a whole lot better about being much faster, and it only rebuilds what it needs to. So look how fast. The first time took a little while as it's downloading stuff and compiling stuff, because it not only has to download these, it's compiling them as well. But now, look how fast it runs. Very fast. Very nice. All right. Let's go ahead and start updating this. So what we'll first notice is that we have this this Tokyo. So we're going to do Tokyo main here. That you'll notice is here. So this is what it looks like, Tokyo main. And this is a procedural macro that basically puts this inside of a Tokyo execution environment. So it's taking your whole main function and putting it inside of a execution, a thread execution, which is going to allow us to use async and await. Now, this is something that we will be rectifying. Macros don't work on my machine right now. They'll never actually work. I'm glad it's coming up with a name for me. They won't actually work. And I don't know why. I've broken my I have broken my install for some reason. All right. So another reason I need to, when we're doing my new thing, I want to be able to quickly and easily go to one that doesn't. I want to have a Vim environment that doesn't have Copilot installed. I want to have 2 because of this. When we're doing this, I don't want to have the hallucinations plaguing this. So next week, hopefully, we'll have that turned off. You know what? I forgot to update the titles. Let me do that really quick. There we go. Titles are updated. All right. Yeah, so that's a thing to do. I don't want that out there. Okay. So let's keep looking at, so we got the Tokyo main and we kind of understand a little bit what it's doing. We're not going to worry about tracing right now. We're going to add tracing later. So let's start building our app. Axum is actually really easy. All you do is you do this router. If you come from Go, it's actually very similar to like how you would do it with Gorilla Mux or any of those. And this is actually really easy. So basically there's just these functions we're currying here. So basically this is kind of your builder pattern that you're doing here with a little curry. And you can pass it these functions. Basically this is a GET request and this is a POST request. And this is a great little example. We're going to start with a simple GET request and we're going to build from there. So let's go ahead and do that. So we can do let app equals router. So we can do this and it's going to include the Axum router in our use there. If yours doesn't autofill for you on there, you're going to have to do that. And then we can do new, and we could leave it at this, but remember this is not mutable. So let's actually change some stuff to this. So we're gonna just go ahead and hit return. We're gonna add a route. We're gonna add this to the base route. So let's just add this to the base route, like Copilot is so nicely recommending to us. And then let's go ahead and give it a route. Now, we're not going to do this. This is actually just a inline function here. So this is an anonymous function. If you're coming from Java, I believe that's what they call them, an anonymous function. We're not going to give it an anonymous function. We're going to actually make a function for this, but we're going to just call get. You can see that this is where get comes from. So we're just going to actually use get. So you could do another statement like this. We can do use Axum handler get like this. All right. And so then we can just call get directly here. Not there. Here. All right. So now we can just use get instead of the fully qualified name, which makes it a little bit simpler. If you had another function you wanted to be called get, you obviously couldn't. Now we need a function to put in here. So right now this isn't really good because we need a function to put in here. Right now it doesn't do anything. All right, so we're going to create another function, and we're just going to do function, and we're going to call this root. I hate the word root, but we're going to call it root for right now because it's the root directory that we're getting. So we're going to do this, and this is a static string. What is a static string here? Why are we doing this? And the answer is, trust me, this is what... just trust me. And actually, this is... Copilot is giving us what we want to do, so we're just half of what we want to do. All right, so we're going to want to do this. This is a lifetime of this string. And basically, what this means is that this string will exist for the entire lifetime of your application. A lot of times you won't see this, but it's true. This is going to, because it gets compiled in. This string right here gets compiled into your application. It's going to exist the entire time your application is running anyways. And so this is fine for right now. Yeah, you're right. I do need to make these async, and it's hard to catch because mine is not. You know what? I'm going to open this in VS Code because VS Code's not having the problem right now. And a lot of you guys were using VS Code anyways, so let's go ahead and open it up here. So let's see. Live learning day 2. Oh yeah, the result. That's what you guys want. I have made it's at like 4/5 of it already, but I'm not checking that into source control. All right. So let's see if that's not working because you're right. These were supposed to be async. That's a good call. Your main function can't be async, but this is kind of what allows it to be. But all of these need to be async. And this is actually going to be important when we get into sharing state. So one of the cool things that the to-do list allows us to do is share state, which I thought was a really cool lesson. Good call out, Twitch chat. Thank you very much for that. I was coding the result at 1:15 a.m. without you guys. Absolutely. That's why I was late. All right. I want to make sure that I have a place we're going and have a plan for each of these. So yes, I do have a plan, but I also want to leave it open. If we have questions on a thing and we want to take a tangent and explore, we should be able to do that. They shouldn't be so strict. It's supposed to be very practical. So These are now async. What this means, what you get with an async, I have a YouTube video if you want to go deeper, but it means that this actually returns a future that's awaitable, which is important. But as a practical guide, I just want to use it. I just want to use it. I don't want to dive into async and await. I want to use these things. Is it important? Yes, it's very important, but I want to use them. All right, let's see if this runs. Oh, wait, root. So this is our function here that we're calling here, and it has no arguments. So this is very similar to just what they're doing here with their root. Very, very, very similar, and that's fine. So let's see if this runs. Let's run it. All right, we have some errors. No get in handler. Wait, where do they import it? Did I import it wrong? It's routing, not handler. It's routing. My bad. There we go. That should fix that. Okay, could not compile. Must be known at this point. We have a Tokyo multi-thread, but the multi-thread feature is disabled. What? Oh, wait. So this is, if you're getting weird errors like this, check out the example. Go to the example project and check out their cargo toml. Because we didn't do this. And I recommend, when dealing with Tokyo, going with full. Because it's the easiest way to not have these types of problems. These exact type of problems. So I definitely recommend, when you go into here and you use Tokyo, to go ahead and basically just update this to have full. You can pick and choose later on in life when you're more familiar with it. I'm super used to Vim motions at this point. So I apologize. I'm going to be a little bit bad at this right now. I'm really bad at brackets because those are on a different layer of the keyboard. So I recommend using full, just because it's going to keep it easier. Oh my gosh, I missed that. No, that's not what I want. I wanted that. Oh my gosh. All right. So that should clear up this. Okay, so see how all of this got cleaned up because of that? If you're seeing that, you're going to want to, it's indicative of that you didn't actually include all of that. Okay, so we still have an error, and this is fine. Errors are part of debugging. And part of learning Rust that I don't think is covered is learning to read Rust errors, because the Rust compiler is actually really helpful. A lot of people think it's really angry, and it's kind of a little angry, but it's actually really helpful when you get to learn to reading what it wants. It's actually trying to help, and it's giving you a lot of information here. Now, this information might not be as useful to you guys. This right here might not be as useful to you guys as it will eventually, just because of type must be known at this point. So basically what this is Rust is a statically typed language. And that means that every single thing has to have a known type. It has to have a known type. And it's saying it doesn't know the type at that point. So we can go back to the example to see where we screwed up. Where we screwed up. Here we go. So what it needs is a known type. And what it doesn't have at this point is a known type. And so Rust can actually get that type for you as long as it has enough information. And what we haven't done so far is actually listened to it. What we haven't done at this point is actually listened to the application. I actually need to put this on my code tab because my fingers go back to this. So let's get rid of this. Let's close this down until I fix that problem. Next week, we'll be doing it in VS Code. We'll move this to the right location because that's where I will go back to. Okay. So the only thing we haven't done at this point is this right here. I did Control Shift because I'm used to. All right. Let's make this correct. Shift Tab. Okay. Done. And now let's run. Now you might be wondering why this all of a sudden starts working when all we did was add code. How does Rust know that what app's type is now? I didn't know it just a second ago, and we just added code. And that's because Rust is fairly good at understanding the data types. And I covered this a little last week. Let's terminate that. So basically, it can determine here that app is a router based off of further information in the app. So here we have serve, and this further limits what it can be based off of this. So this is where, like, again, if we go back to last week's example, we had a function that took an I64, and when we did let, it deduced that it needed an I64 because it was used in an I64. Now, if you tried to use it in an I32 and an I64, it would complain because it can't be both. It can only be one concrete thing. Okay? So, this is cool and working. Now, if we're really working, we see that it's binding to port 3000. We can actually check and we can curl this. So let's go ahead and run this again. And see if we get hello world coming back on port 3000. We should be able to curl port 3000, curl HTTP localhost port 3000. We could actually use the command curl HTTP localhost 3000. And we get a hello world back. We are actually actively responding to this, and it's awesome. Everything is awesome. Everything is awesome. Right. Okay. So, and this is what I was trying to point out. And what I want to do. I'm not going to take us down a happy path where we have no errors. I have written all this up. I actually don't have it actively pulled up. I can pull it up for reference. I have no screen with it up because I want us to hit stupid errors, and I want us to read the error message, and I want us to understand that the Rust compiler says it is angry because it's trying to make your code correct. It's trying to help you get your code to a place where it will run without errors. That's the general idea. Now, I want to make a call out right here. We do this thing called unwrap here. Unwrap is a way to get your application to panic. Now, I think this is a great way to get your application to panic very quickly. Here, it's kind of an acceptable place because basically the reason this would fail is if it couldn't bind to port 3000. So we can do this. We can do this to ourselves we can run here. So let's run here in VS Code. And then let's try to run here. If we do cargo run over here, guess what? It's going to panic. The address is already in use. So maybe you could make the argument that this is an acceptable place to use panic because at this point, there's nothing more for the application to do other than to panic. I mean, we can't bind to the port that we were told to bind to. Now, this kind of sucks because we're only using one port. So let's actually change this where we can bind to any port that we would like because we should be able to bind to any port that we want. And then we did this a little bit last week. We used clap. So let's go ahead and look at clap again. Clap. And we're going to use clap. We already got its latest version. We can go over here to look at clap's dependencies. We already got derive though. So let's go ahead, click on the examples. I'm just showing you guys how, if you're new to the area, to go through all these things. So in here, there's two things. There's the documentation and there's the Git repository. You can open either one. The docs.rs is fantastic. Sometimes they don't have quick start guides, but you can see a derive tutorial right here. Cool, that's what we want actually. So here's their derive tutorial. They'll actually tell you how to add it with the feature derive as well. We already added this though. You know what, I shouldn't have done this. In the future, I'm not gonna do this. I'm not gonna add derive until we find that we have a problem and we need to solve it. My goal is not to solve every problem before it happens. My goal, because I think people get stressed with Rust because they'll try. You know what? Let's actually remove this and see the error that we get. Let's see the error that we get. That's what practical Rust is. Let's oh gosh. That's what practical Rust is supposed to be. All right, so we removed it. Cool. All right, so this is what we're going to do. We're going to make a struct. We're going to derive the parser and everything. So let's just copy this really quickly. No, I'm not going to copy it. We're going to just type this. We're just going to type it. It's not that hard. Let's type it. So we're going to create a struct that represents our command line args. Right now, we only have one. We want the port number. So let's do that. We're going to type out struct. And we'll call these CLI args, not arts, args. Okay. And let's see. CLI args. These args, we're going to have one thing. We just want a port. What is that port going to be? That's going to be a string, I think. Yeah, we'll just have it as a string for right now. It probably should be a number, but string is going to be easier. I'm just confusing the crap out of myself. I'm trying to use Vim motions. I've been using it so much recently. It's hurting me, especially with this split keyboard. I haven't done anything but Vim motions with the split keyboard, so I think that's doubly bad on my part. Okay, so we have this, but these aren't CLI args yet. We learned this in the last one. We need to actually do the clap derive. So this is what they're doing here. This derive parser. We want to be able to parse these args. That's what gives this this parse function on that object. It makes this function on that for us. So we want to derive parser for it. We can derive a lot of stuff. Parser is just one thing that we can derive. So let's derive parser. And this is where we're going to see our error. Now, if you'll notice here, we have to include parser. So we're going to actually do this right here. We're going to actually do the use statement, make sure that we get it in there. And I'm going to actually show you guys how to do this a little bit neater. This is not as neat as it should be. Nope, not that. Just that right there. Parser. Okay. So we've used this. Now we'll see that there's an error. Cannot find derive macro parser in this scope. So this is what it looks like when you don't have a feature that is a macro. It's a little bit of a confusing message, but it kind of makes sense when you see it. So basically, when you don't include a feature, you don't have that code. You don't have that code. And derive is looking specifically for a macro. And so that's what it's telling you is cannot find derive macro parser in this scope. It's saying that we see that you included it here, but parser is imported here, and it's saying that on line 3. So you can see on line 3, parser is imported here, but it's only a trait without a derive macro. And so this can be a little confusing, but it's not actually that bad. It means we don't have the derive feature. And this is why I'm trying to go over these things. Like I think this is something that people get hung up on, and I don't want it to be something that people get hung up on. I also wanted it to be this class. Like I feel like maybe it feels simplistic, but I don't know why I'm struggling hitting that stupid key. I know it can be, this feels really simplistic, but I feel like this is a lot of people's problems with Rust, is they get into these things and it feels too hard, even though it's trying to tell you what's wrong. So this is cool. This is really cool. We now have it working. We figured out the error. Rust is there to try to help you. It does a pretty good job once you learn to read it. It can be a little bit, but okay. So we've got this working, and it's kind of happy. It's kind of happy. One thing, you see these curly braces with your imports. You can actually use these to clean up your imports. Now you'll notice this is saying I don't need to do it, but I could do it up here. This is really cool. Practical Rust here. Practical Rust. Let's clean up this import here. So what we're going to do here is put a curly brace around this, and then we don't have to repeat the use and axum here. So we could literally do this. Okay. We can literally do this. Not that. Don't do that. Okay. And then we're going to clean this up just a little bit. Okay. It's unhappy. We need a comma. There we go. All right. So this is a little bit easier to read. So basically you can import multiple things, and that's what it's complaining about here is you don't need the braces if you're only pulling in one thing. This had subcommand. I actually don't think we need subcommand, so it's probably right. We don't need the braces here. So let's just remove those. We're just importing that for right now. So that's a nice way. This is also if you run Rust format. So let's actually run Rust format and see what Rust format does. This is something that you should run before checking in your code. It makes it idiomatic Rust. So let's undo this really quickly. Let's undo what we've done here. I just wanted to show you what was happening here. And we're gonna start back here. We're gonna save this, and then we're gonna go and run cargo fmt. And this is gonna run basically Rust best practices on your code. I thought Rust format updated these. Well, there you go. I learned something new. Rust will leave it like this. Rust FMT. Does it really? Okay, never mind. Scratch that. It did remove the parentheses around this. So it did what this was warning about does. We need to configure it to do the other, I guess. All right, well, cool. You notice that this was getting a warning where it was saying you didn't need it. You didn't need these, right? And you're getting this, unnecessary braces and if statement. So it did clean that up. It's going to also clean some other stuff up. It does a lot of stuff with your formatting. So it cleaned that up. If we did something like this, watch this. Let's be a little bit of a bad citizen here. Have some random tabbing going on here. It's gross and ugly. Well, guess what? We can fix that. Rust format, super powerful, should be running. And you should be validating that code gets checked in, gets that run. All right, let's validate this. Merge imports. All right, so import granularity crate instead. All right, so there is an option to do what I was saying. We'll look, you know what? We'll do one of these classes on configuring stuff. Yeah, we'll do one on configuring stuff. I've actually never configured format, so that will be good. I've never done it. I thought that it did this though, so maybe I have done it and I just don't remember. Thanks for the follows, by the way. I hope you guys are enjoying this. I hope that this gives you... I hope this brings a very practical, very hands-on. Is everybody following? Do we need to pause? Does everybody have something they can access the port at? Access the port at? Does everybody have something that is listening at this port or any port? I don't care what port. Give it a port. That just responds back with hello world. Hopefully your silence is a yes. It could be that you're working and I've gone too fast. So I'm going to just pause a little bit. Thank you so much, Cypher, and everybody that is contributing to catching my mistakes. Cypher, Future Highway, Russell, I know you all have caught my mistakes. Also, you guys have really great feedback. Thank you. And I'm sure I'm missing somebody, so I apologize if I missed you. I think that this is a great way to do this. All right. So I'm going to assume, since you guys haven't said anything, that you're completely swamped, but I'm going to have to move on anyways. I'm just waiting. All right, we're going to move on. So we want to be able to set this port dynamically. So this brings up some cool things. We're going to use our new parse. So all we have to do is our CLI args, these right here. And we can just call parse. This would work great if we actually assigned it to something. I'm sorry, I'm hitting my my Vim bindings. All right, so let's set this to something. Let's do let args. I don't know why I'm keeping doing arts. Args. Equals this thing here. Why is the syntax of Rust so much more complex rather than something like Python or TypeScript? So generally, the reason it feels more complex is it's more expressive. And the reason it's more expressive is it's actually more explicit. We can get into the crazy things that you can do with Python's and JavaScript's type system that are almost impossible to understand what's going on without actually running it. I can write Python code that you cannot tell me, and not a long piece of Python code. You can see all the code in one screen, and you can't tell me what type the end variable is. That's not true here. That's not true here. The reason people that learn to like Rust is because the goal is Rust tries to make sure, to the best of its ability, that if the program compiles, it also runs. I know that that sounds weird, but Python, JavaScript, whatnot, it's very easy to compile code that doesn't run. It's very easy. All right, we're still actually running, by the way. We never stopped. It's very easy to actually compile code that doesn't run. Okay. So yeah. All right, we got our args here, and our args should have a string, and they should be mandatory now. So actually, if we run this, and you'll notice that this is saying that this isn't used. Again, Rust is trying to protect you. It's saying args is never used, and it wants you to deal with it. There's a couple ways you can deal with it. If this is a true that you don't actually want to use them, you can preface it with an underscore. Now, Togglebit brought up a really good point. There's a difference between this and this. So these two are very different. In this one, this is a thing, and its scope is held till the end of the scope. In this one, it is not. It is freed immediately. So if you're wanting to ignore it, but you want it to stay an object for the end of the scope, you need to do this. Otherwise, you can do this. It's just an important distinction between the two. Maybe we'll explore it more later. All right, our goal is to actually use these, but let's go ahead and run it because we want to see if what we're doing works. So again, if you're in Visual Studio Code, you can just do that, but you can also just do cargo run. Right. Yes, Dirk. They'll run or they'll run, but either do the wrong thing or they'll crash. That's the idea. So we can see that we actually run now, but we crash. But we crash on a check that we wanted. The following thing isn't provided is port. We didn't mark it as optional. We did that last week where we made this an option, and we didn't do that. So Clap takes this as this is a required thing. You have to pass in a port. We need a port. So when we run, we want to pass in a port. We'll pass in a port of 3000. And now we're running on port 3000. But this is kind of weird. I'm not going to lie. I don't love it because passing in a port like that is not usually. Usually you want to do something like this. You want something like this. Port 3000. This is what you really want to do. But we don't have an argument. We have an argument. We don't have a flag. So let's actually try to update this so that we have, port shouldn't be, it should be a flag. So let's do that. Can I do this from memory? Probably not. I don't type this nearly enough to do this from memory. So let's cheat. Let's cheat. Let's go back from the docs. I cannot remember it for the life of me what it is. Clap. All right. This is what it's a right here. We got it. We want a short and a long, and we're not going to give. Actually, this we can give a default value, but we're not going to for right now. We'll just do this right here. Cool. It's arg. I forgot. I don't do it nearly enough. So there's actually a project that supposedly leaks memory in Rust with only safe Rust. And I actually want to dig into it because I want to find out how they did it. I think that would be a cool learning experience. So if you guys would like to do that, let me know. I don't know how they did it. Toggle said it's very creative, very purpose-built and creative. So I'm kind of interested in understanding. So let's go ahead and run this again, see what we get now. All right, so now, okay. This is because we gotta actually this is on me. Instead of passing, this is getting passed to cargo run. We want to actually pass it to our app. So to do that, you have to do this to pass it to our application. All right, so we're now passing it on this. Let's actually run it without port again to see what the error is. So let's cancel and let's just do cargo run again. And now you can see that we have a flag port that takes the port. Super cool. Super cool. Okay, so it's non-optional. You gotta pass it in. If we do cargo run and we do this, we have a help and we can see that it has the port. Now there's no descriptions and we can make this better and we'll do that in the future. But we want to do one last thing because this class has already gone on long enough for today. We got to do one more thing. We're not actually using port. You'll see that we still just build this hard-coded string. Rust can't prove that our application is correct, but it can try. And you know what? One thing that would make us think about this, so before you ignore these things and before you put the underscore on here, think about why aren't you using this? Because this would tell us, this right here, this warning right here would tell us that this isn't being used. And if you have something being compiled for production, I would fail on this in your tests. If there's this warning that's happening, it needs an underscore. And not only does it need an underscore, but before you put an underscore on there, why can't it just be deleted? Why not just delete it? And if you can't delete it, should you be using it? And if not, then put underscore. That should be how you think about it. All right, let's do this. Okay, so we want to put 3,000 on there. A lot of you are going to think, well, let's just do this and plus args dot port, which is a string, right? This is what we want to do, right? This doesn't work. Why doesn't this work? Let's do this. So we have a owned string on the left and a borrowed on the right. All right. So they have a thing here. So they say we could add a borrow on the right. So we could do to string, which will add a borrow here. But this then says we have an own string on the left and a borrowed one on the right. Doesn't really fix it. But you know what? There's an easier way. And the fact of the matter is this isn't a string. This is a string. This isn't. This is a stir. It's a slice of a string with a static lifetime. And so we could call toString on this as well, just like this. And we can see what error we get here. And we can see that expected a stir and found a string. So then we could be like, what? We could do but there's probably a little bit of a cleaner way of doing this. A way I like to do this a little bit better myself. So we're going to use another macro. And we can just do format. It's a good old format macro. You'll see the exclamation here. That's saying that this is a macro. So there is some code being generated for this. And we're going to format this. Okay, so in Rust format strings, you can just do this. Watch this, colon, and then we're going to do just 2 curly braces, and then we're going to add our string over here. So we're going to do args dot port, just like that. And all of our problems go away. All of our problems. So format's really powerful. It's a really nice and clean way to see how it is. I like it. There are other ways to do it, and we'll expand on those. But let's go ahead and see that this works. Let's go ahead and check out that we can run this with a port of 4,000. And you know what? Then we'll have to open up another terminal. Go ahead and open up WesTerm, and we'll make a curl here. Curl HTTP localhost 4,000. I can't spell curl for the life of me. And we get our hello world. All right. I have literally misspelled curl twice now in 40 minutes. Fantastic. Fantastic. Okay. So we have created a very, very basic HTTP handler. We have configured it via CLI args. And yeah, it's pretty awesome. Good job. And I hope that we learned a little bit about debugging Rust. I hope. How's everybody liking this? Has it been helpful? Is it useful? Is this a good way of approaching Rust? I wanted to create something where it was more approachable, where we covered practicality. And I know that we do this in stream too, because I just screw up on stream and we have to debug it. But yeah, I'm also like, so I can show you, like, I have this whole app already written once, because I want to make sure that we're going towards something that works and is pretty well and clean. And so like I have this guideline, but I'm also trying to keep it not like, hey, I have the perfect path and we're just going to type it out perfectly. Because I want us to experience those things and learn to deal with them. Because really, I think it's a shame that people hate the Rust compiler and the type system, because those things are there to help you. And they're actually really good at helping once you learn to speak their language. I feel like they speak a version of English that maybe is a little bit more difficult to learn. So, yeah. And then I'm going to make these into YouTube videos. The videos are on YouTube. These are all saved on YouTube. Last week's are getting split up right now. My son is working on splitting those up. So that we'll have just the Rust ones on the null bytes. So by the end of this weekend, they should be up, or Monday, maybe latest. So, but the full streams are up there. So I'm gonna post this repo with all of the stuff that we do here, which has the live streams in it. So if you're looking for everything that we do, that's where it is. GitHub. So let's go learning. This is the repo, and there is the Nightbot thing, but you can also, that is the specific repo. Thank you for testing out that the Git commands work, the GitHub commands work. So anyways, it has all the information with like where the live streams happen. So the live streams happen here on Twitch, but I do also restream it to this YouTube, because Twitch doesn't keep the VODs forever and YouTube does. So this is basically the way to keep the VODs forever. So you can go ahead and find those. And then I do cut these up into bytes. My daughter, my son, and I work collectively to do that in our spare time. So they're about a week behind at this point. So I apologize that we don't get them out faster, but it is what it is. It's the amount of time that I have. So yeah. Anyways, cool. So that is Rust for today. I didn't get quite as much. We were actually going to I wanted to do state on it a little bit, but we didn't get to using state. So some shared state, that will be next week. That will be fun. And we're gonna next week. Thanks for the follow. Next week we're going to basically add the 2 to-do endpoints where we're going to be able to return, and we're going to be able to create to-dos, and we're going to share some state between those. And that will be our goal. And then we'll start doing like a data store after that. So I need to pay them more. Probably. probably would get them to work more on it. You're probably not wrong. You're probably not wrong. I do actually pay them for it, though. All right. All right. Let's jump into the Kubernetes one. So we're going to start out really simply. I was talking to you, a lot of you. I was going to jump straight into Kubernetes, but some of you didn't even know what a container was or how to make one. I'm not going to go into the theory. You can check out my main YouTube channel for more information on just what a container is and how it works. But we're going to do really quickly before we do anything, how to make one. So our first Kubernetes thing is going to be how to make a container, because you got to at least understand that. Oh dear. So you got to at least understand that before we can actually move on to anything Kubernetes. Okay. Intro. What is a container? That's the first thing we're going to ask. What is a container? Why use a container? And how to build a container. These are the questions that are burning in our mind that we're going to try to answer today. Now, if you haven't installed Docker and you're on Linux, I would install Docker. There is this thing called Docker Desktop for Mac and Windows. I don't really care. You can use Podman as well. I don't really care what you use. I'm not going to go through the installs of setting up whatever you use. Know that Docker Desktop is not an open source project and has licensing for it. I believe if you're an individual, you get to use it for free. I don't know that off the top of my head. If you're on Linux, you don't need it for the Docker CLI. You can just basically use containerd and be free of it. So anyways, go ahead and install Docker. You can search it, you can Google it, and you'll be able to find it. You can ask ChatGPT how to install Docker, and it will probably give you a virus. But yeah, go ahead and get a Docker-like thing. You're going to need it. You know what I should have done is I should have put a marker. I'm going to put a marker now because this would make our editing post so much easier if I put markers in the videos. So we're going to do containers. Done. Should have been doing markers. Okay. Well, nailed it. All right, so go get Docker. Install Docker on Linux. Boom. Do this if you're on Ubuntu. If you're not on Ubuntu, go find your own instructions. There's instructions for everything but Arch, because Arch has its own instructions, because Arch is awesome. If you're not on Linux, I don't know how to help you. There might be somebody in chat that does know how to help you. So if you need help and are struggling with that, speak up. Hopefully there's somebody that runs on your crappy system. Yeah, for those of you on Arch, if you're having problems, let somebody else know as well. I'm not an Arch expert. I just use it for the memes. All right. So what is a container? Let's start with what is a container. This is actually really simple, but we're going to actually draw a little bit. Create a new drawing. And we're going to name this what is a container. Rename what is a container. This is really, really simple, but so many people get it so wrong so quickly. In the classic sense of running, something that people equate it to a lightweight VM, and that's just really wrong. And I want to get that out of the way. So in the classic sense of a VM, you have these things here that sit here like this. And these are, this is not a VM. This is like your hypervisor. All right, you know what? We have an ad break, and I've been snoozing it, and I can't snooze it anymore. So you guys are going to be subject to an ad. And so we're going to pause. We're going to pause because some people are going to be subjected to an ad, and I can't. I've already been snoozing, and they only allow me 3 snoozes a day. So I'm sorry. I'm sorry. Your 50 cents now belongs to me. Go stand up. I'm going to stretch. If it's an ad for Kubernetes, that's fantastic. Like, that means they're listening to the stream, which is fantastic. That would be, tell me what the ad's about, okay? I'm going to stand up too. Okay. Actually, what I want to do at some point is I want to have subscriber only Wordle. Twitch plays Wordle. I want to do that for subscribers when ads play. I think that would be fun little bonus that you get. So there's a reward. You get to chat with me as well. I don't know if that's a reward. Maybe that's a punishment. You're stuck with me. Everybody else gets to ignore me. My goodness, we still have 2 minutes, 20 seconds. I ran up and down the steps once. I thought that I was slower than that. All right. We'll wait for the ads, though. Docker Netties. It's called Swarm. You're out of ads? Awesome. I have this little thing that says ads are playing, so I assume that some people are still getting ads. Hopefully it's accurate. Togglebit, I would love it. You want a co-stream? 100%. I would love somebody to teach me some advanced Rust. I think that would be super cool. Because like I said, I can use Rust. There are aspects that I'm looking to learn in the future. Like an easy one is procedural macros. Don't know how to do them. Pinning memory. I understand how to pin memory, and I understand to do it from C++ and stuff, but I don't know how to do it in Rust. So writing our own future, actually writing our own future, not just using an await, seems like a cool thing to do. So there's so many cool things you could teach me about Rust. So 100% let's do it. Well, you think on it. Yeah, think on it a bit. I would love to. I like learning new stuff. I love learning new stuff. All right. Ad break is done. Okay, let's talk about really quickly. So this is a hypervisor. And if you're using like, I'm going to use KVM, but there's other hypervisors out there. If you're using KVM as your hypervisor down here, you're actually running, a Linux kernel, and all hypervisors have some sort of kernel for their operating system, but you're running the Linux kernel here. And this is important. You'll see why in a second. So then in your VMs up here, you actually have a couple things. You have virtual memory. We'll just say virtual hardware. Virtual hardware provided by the hypervisor. On top of that virtual hardware, you'll have a full OS install. And I know the virtual hardware is kind of, I'm just building a stack because this is a nice looking picture. I get it. You'll have a full OS install. And this full OS install includes user and kernel space. Okay. And then you have your application. You have the stuff that you install on this. The stuff you install. Okay. So this is, and you'll see why I dislike this thing so much. The correlating this to containers. Now, let's draw in containers over here. We're just going to make this a little smaller so we can fit it both in here. In containers, you have the same system, but instead of a hypervisor, we're going to run Linux. Just pretty much any flavor of Linux is going to work. And this has the Linux kernel in it. Linux kernel. Now, a lot of people say that you run Kubernetes on Docker, and that's just flat out not true. So a lot of people would think like Docker sits here and that you run a container on this. And like this provides the stuff of KVM. You could think of, KVM as the Linux sitting down here. You could almost think of, KVM doing this part of it. And, yeah. Anyways, you get the idea. They think of it this way. And I really dislike it, as you can see. Docker provides you the tools to build containers and to run them on your system. But it sits over here. There are other tools that do the exact same thing and can build the exact same containers. This container sits directly on your OS. And furthermore, it doesn't have virtual hardware. It uses the Linux hardware. It doesn't have a kernel. It is only the user space. So this is a container. We'll just draw it big like this and container. And we'll stick that up here on the palette. Where is the tool for this? Yeah, okay, here we go. Got the right button. So we're going to put this, not there, there. Okay, container. We're going to make this VM, and we'll slide that right up to the top too. Just like that. Okay, cool. So this is similar. All right. So in the container sense of the word, we have 1 second. 1 second. I'm so sorry. 1 second. Sorry about today and all the interruptions. All right. So in here, instead of okay, wait, this is the Linux kernel that's sitting down here. My bad. Shouldn't have taken that box. Let's draw a new box because that's what we need. All this has in it is the Linux user space. That's fine. This is it. There's no virtual hardware. There is no OS install. There is no kernel. There is just the Linux user space that you install, which can be very minimal and includes the application, the stuff that you install, that you run. So this is a container, and it runs directly on Linux. So Linux uses a couple things, and we can get more into detail on this. But this container is basically just a jail, and comes actually from work from like free BSD jails. And when you I forget the name of it, where you change directory and you make that the root directory. And why can't I think of the name of that? All right. Anyways, so it leverages kernel level features called namespaces and C groups to do this. Namespaces and C groups. Troot. Thank you, Cypher. I can't read. It's Troot. And C groups. So you can think of namespaces and like, this is oversimplifying it for sure, because we're just starting out. It's just what Docker does is it creates namespaces and C groups for this container that exposes it to some limited network, to some CPU, to some memory. But when your process, and we'll expand on this as we build our own containers, we're going to exec into them and we're going to actually do some stuff and see what they see. They're just in a jail. And that's it. They're running directly on the host. You could run a container and delete Docker, and that container would continue to run on your system. Okay? You can run it without Docker altogether. You don't need Docker. Docker, the command line on Linux, is just a set of tools. Now, this is not entirely true if it's on Windows or Mac, because on Windows or Mac, they actually stand up a virtual machine because this is a Linux thing. And so on Windows and Mac, they actually, you have Windows running here. And what Docker Desktop does is it runs some Linux over here to then run the containers on top of that Linux. That's what Docker Desktop does. It's why we don't need it on Linux, because we're actually running it on Linux. Okay. Does this make sense? It's a lot more powerful than Troot, but yes. Because so Troot just makes that directory, but this is like a whole lot more. So like you can limit how much memory. This is where like C groups comes in. So you can think of like namespaces as the fence, and then C groups is how big that fence is. Like, okay, this is the memory that you can use. How much memory do you get to use? How much network do you get to use? How much, those types of things. But again, we'll get into that more later. But this is the big difference. And why is this a big difference? Well, virtual machines, until like Firecracker and some of those, are heavyweight. They take up memory just managing the VMs. It's harder to pack them because they start up slower, and they usually have larger memory bounds. So you can pack these things really, really tightly. They start up insanely quickly. So yeah, if you don't need the security of a VM, and now I say that because containers do have security implications. We'll get into that more, but they're not technically as secure as VMs. And that's okay for 99.9% of people. That's okay for 99.9% of people. Sassy Fajita, the thing is, yeah, they're cross-platform where when you run containers on Windows and Mac, they're just standing up a VM. And then they're translating all the calls when you do like Docker PS and all those things to that VM. And they're just shipping them to that. That's like, I'm oversimplifying it, but that's what it is. So that is what a container is. Okay. Does that all make sense? Can we move on from that? It's also why to use a container. Why use a container? Well, you use a container because it's easier to pack, it's easier to manage, and because you want to use Kubernetes. Okay, Kubernetes doesn't manage VMs; it manages pods, not even containers. All right. So, does that explain it, or do we need to go into more detail? I don't want to stick around too long because like this is really, really basic, but I do know there were some of us that were confused as to what containers were. So before we dove into Kubernetes, and these people wanted to learn Kubernetes because you know what? It's a thing in the industry that you probably should know of. If you don't have to use Kubernetes to do a lot of stuff, but if you're wanting to learn it, it's a good thing to learn. Okay, so let's move on. That's what and why. That is what and why. So what is a container? It's a Linux process put in jail. That's the easiest way. It is literally a process put in a jail. Your process, the process you want, put in a jail. Why use it? Very lightweight, easy to pack servers, little overhead, fast startup. Okay. There are some more nuanced ways. We could talk about reproducible builds. They don't solve reproducible builds, but they can help with reproducible builds, or at least better. Better. They're not perfect at this. So they can help with that. They can also make sharing easier sometimes. So one thing that I love with containers is the easy way to share a build chain. So if you're talking about just containers, have you ever downloaded? So back in the day when I was learning to code, back in 2014, when I was learning to code, I learned C++ because I didn't know better. And I just picked C++ because it sounded like a good thing to learn. And it was a good thing to learn. I learned a lot of painful lessons from it. But every project that you would go to had their own build chain, and you'd have to set up your computer. What's really cool is you can codify that build chain into a container. You could say, hey, here's your thing, and I don't need to screw up your computer's install for you to leverage this. It's actually really powerful that way as well. So it's kind of a interesting way to share environments as well. Okay, so those are some of the reasons why you would use a container, and you're going to see those as we go on. So how do we build a container? Well, you build them through this process of building layers and things like that, but there's a really simple way, and it's called a Docker file. A Docker file is a file that can be read by the Docker command line and build a container based off of it. Now, there's actually a bunch of other projects that do it a different way, and those ways might even be better than a Docker file, but we're going to stick with a simple Docker file for now. Now, we have some code that we've been writing, some Rust code. We're going to build a Docker file for this, but before we do that, let's just build a simple Docker file off to the side of all of that. So we're going to open up a Wes term here really quickly. And we're just going to cd into code temp tmp, and we're just going to make a Docker file here. It's Docker file. There's no extension. This is a Docker file. Okay, so there's basically just a few things to do in a Docker file. The first is to pick a good base image for your thing. We'll get more into that as we do more. But this is a from statement here. So you just do from, and there's a bunch of containers out there that you can pick from to build your container on. Now, one that's come up recently that I really like recommending, because I have actually really liked this is ChainGuard releases a bunch of really good images. And they're also on Docker Hub. So if you're looking for images, you can go to Docker Hub and check out this. Yeah. So there's a bunch of images on Docker Hub, and you can go and get those images as base images. So let's look for a good one. Alpine's a great image if you're wanting to. It's a very slim image. If you're wanting to get Alpine, let's see, 317, you can go here and you can pull this Alpine 317. So we could make this container from Alpine 317 from here. And so we can say from Alpine 317. And so that's picking our base container. It can be anything that you find on Docker Hub, or Google releases some containers. There's a bunch of containers out there. Now, if you're writing Go, there's a Golang container. So you can just do Golang. That's a container right there, which is a pretty good container for building a Go application. It has the whole Go compiler chain in there. There is a good Rust container as well, so you can just pull the Rust one, and we can go check it out. Let's go look at it. We can go Rust. Check this out. Here's the Rust container, so you can see their Rust container. I have built Scratch images. We can talk about that. This is a very basic. I don't want to get into building good containers. That's like, if you guys want a class on building containers, it would be like a 2 or 3 weekend class. We can do that, where we dive into how to build containers, how to solidify them. Today, we're not getting into multi-stage builds. We're not getting into best practices. We're getting into, like, can we make a container that's ours? That's what we're looking at. All right. So really good question, Sassy Fajita. If you're running Alpine Linux on your machine, if so, why use an image that does not equal your OS? Okay, so this is going back. This is actually a really good question. If we were in a container or a VM world, you would probably pick a OS here and have all your VMs use that OS. The thing is, you have to stop thinking about a container as an OS. It doesn't have a kernel. It doesn't have a kernel stack. So the reason you pick a container is for whatever user space that you want. And what a really good thing that was being brought up was, in the end, if you're making a really good container, you probably don't want any user space. You want as little in here as possible. You want, if you can get away with it, you want just your process, just your Linux process. You don't want anything in here that you don't need or want. And we'll get into that. So you have to stop thinking of this as an OS. Now, I know that we talked about Alpine, but Alpine is basically just a collection of the very basic necessities that you need to run some programs. Rust is the basic necessities that you need to compile a Rust program. It's not an OS. Don't worry about the OS here. It's not an OS. It's not an OS. Right, Cypher. Cypher also said it. Sorry to harp on something that Cypher said so elegantly in chat. So you're running that image because its default user space makes sense for what you need to run. Yes, that's the whole reason you pick this. Somebody brought up Scratch, and you can do from scratch. I don't know if it's in here. Basically, Scratch is nothing. Scratch is nothing. It makes a 0-byte image that has nothing in it. It literally has no tools, nothing. If you tried to build a Go application, it would complain out the wazoo. If you tried to install Go in it, it would say you don't have any a package manager to install Go. So then you would try to tar it from, or you would try to wget it from Google, and it would say wget's not installed. Scratch is painful. But yes. Maybe, yeah. Cypher, yeah, your app has to be statically linked, sure. Or you have to it doesn't have to be statically linked. You can just include the things that you want to link into your image. So you don't want to statically link to OpenSSL, you just include OpenSSL into your image. So you can definitely include stuff in there. You can bundle whatever you want. But the idea is, and this is why it helps with, I said it doesn't solve reusability and reproducible builds, and we can get into that, but it is pretty good because basically you can define exactly what's in that space, exactly what your application can call and can link to. And so you know that this is kind of a bundle that works in theory. It's not perfect. Dirk, you said something very spicy. I think we should stop using images for distribution. I don't know exactly what you mean. This is probably not the best time to discuss that, but I would love to discuss it with you. Get your thoughts on it at some point. Okay. I just wanted to let you know that I wasn't ignoring it. Dirk is with you on NPM for distribution. You can put Nix in a container. Did you know? Have you done that, Dirk? Wait. There you go. Here you go, Dirk. Nix in a container. Oh, wait, did I miss Sassy's? Wait. Oh, okay. Sassy, I'm sorry that I missed your question. The container image matching the OS. So in general, no. Let's write this down here. Does container need to match OS kernel? And so the answer is generally no. There is cases where this can be a yes. And if you're doing this, I will explain now. Okay. So the reason I say generally no, if you're looking at this as just a Linux process, then no, it does not. No, it does not. And if you're doing microservices, it will never need to match. Never. Because all this is a process. Now, when does it matter? Well, if you give this elevated privileges, so you bust a hole through the side of your prison, and you allow this Linux process to call in here, ruining every piece of work that you've done to encapsulate and secure this and give it elevated privileges, you can call Linux kernel things from your container. So you can call Linux kernel things. And in that case, you would need to know your Linux kernel. 100%. 100%. Because you have destroyed the sidewall of your container prison. So in the general case, the answer is no. When you get to a place where this is not true, you'll understand. I think is the answer. Is no, you don't. And when that happens, you'll know. The one time, another time that I've seen it is if you're building C. Because if you're building C and not statically linking everything, the glibc stuff that you include, if it's not matching what is in the OS, this can cause problems too. So we'll put these as times when it can possibly bite you. This doesn't bite you if you just statically link everything in glibc. It just bites you if you're depending on the Linux version, which some things have done. Okay. What is a container? That is what it is. How to build a container. Let's keep going. All right. Obviously, we're picking from these, but we said let's look here at our thing. We said from Rust, okay? And we can give this a version. I think 174 is out, so we'll do this version of Rust. You could pick whatever version you wanted to build from. But what I want to point out, this is a container as well. We're starting it with our base, but let's jump over here. Let's cancel all this. Don't need any of this. Let's do this. So let's do this. Docker pool. And if you're looking at, we did Rust. Let's just do Rust. Docker pool Rust. This is a container we can actually run locally. Any container that you can run can also be a base. Not that you want it to be a base per se, but it can be. So we've just pulled the Rust latest. If you don't give a tag, we could do Docker pool Rust 174 like we did in our container. In the container, we specified a specific one. Thanks for the follow. And here, you know what I didn't do? I didn't update the description. We're not learning Rust now. We're now learning containers. My goodness. One of these days, I'll be decent at streaming. Okay. So this is pulling the specific version. Now, how would we access this? You can look at the Docker command line. You can do help. You can do Docker images, though, is how we list all the image. Oh my gosh, how many images do I have? My goodness, that's gnarly. That's gnarly. So we need to clean that up because this does not make a very good. You can see Rust hidden right in here. Oh, that's not even the closest one, though. That was a long time ago that I pulled that one. Oh my gosh. All right, here we go. Another Rust one. Here we go. Why does it say 3 months ago? We just pulled this one. That's a lie. That's a lie. Oh, this is when it was created. So this is when it was created. So that was created 3 months ago. That's fine. It wasn't created today. Well, we want to create an image that is created today. And that's what we're doing. That's what we're doing. Okay, so from Rust, but we're not doing anything in here. Well, I should have pruned my system. Should we do that right now? Yeah, well, let's do that. Docker system. It's prune, right? Just prune. What is this? All. Yeah. I should have done that before this. So Docker system prune. One thing that can happen is these containers and images can take up a considerable amount of space. If you look at this, these are each 3 gigs, 3.5 gigs. So whatever this is taking up considerable amount of space. Same here. And so as you go, you're going to get these. Now, not as much as me because these are because of Tilt. That's why there's none and none. Tilt is doing these. This is a tool that we use. Tilt is notoriously bad about polluting your system. But yes, it's fine. Tilt is responsible for all these and these. These are intermediate builds. These are like the builder builds that you're doing. So anyways, why do you see 44 years, you might ask? 44 years is because they set the creation date to 0 for a more reproducible build. So that this is binary compatible with rebuilding the exact same thing again, because the creation date is embedded in the manifest. So we're still deleting stuff. We're going. We're working. Yeah. No, this is just the created date. But you'll see that there's a group of people that do this. That set it to 0 effectively. Which is why it looks like it's from 44 years ago. This is taking longer than I expected it. Some elevator music. Please hold while we delete your artifacts. 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 While you're waiting for your artifacts to be deleted, please enjoy this fantastic elevator music. Sorry, I'm done. No, that's annoying. It was kind of its intent. We could just stop this. It's gotten... Oh my gosh. Look at it go. Well, let's continue on with our image while we're waiting on that. Okay, so we have an image. We want to do stuff with it. But we haven't yet. All right. So at this point, you know what? I want to start with not a Rust package. Let's start with Ubuntu because a lot of people know it. So let's do, instead of this, let's do the latest Ubuntu package. We'll just do, my goodness, fingers typing. We'll just do Ubuntu. And we'll just do 20... Is it 2204? I think 2204 is the latest long term. Okay, so they have an image, I'm sure. You know what? Copilot wants to install dependencies. We'll let it install some dependencies. So maybe you want to do some stuff in this. Ubuntu is a really fat image. It has a bunch of the Ubuntu user space, so you could do probably something like this. We don't necessarily want to, but you could. You can use the run command to run a command in that user space. If apt exists in that user space, you can run apt and it will do apt things. So you know what we're going to do is we're going to run apt update. It doesn't actually do anything. We're not like actually doing like installing anything. We're just going to run apt update. That's all. Now, maybe you want to copy some stuff from your file system. Let's say you want to copy your project. Well, you can use the copy. What does this do? Well, quite literally just copies at this directory to this directory. What's this directory? Well, you can set this directory. This is currently at the root because we haven't set a directory in our file. So you can do, you can do workdir, and you can change this to app. So instead of root, we could be in app. And at this point, this would be this right here, this dot where you're copying to is actually in app. Cool. Cool. By default, Docker can only copy inside the directory it's called from. So you can't do something like copy this thing because that's going up a directory that it doesn't have access to. So you want your Docker context wherever you build from to have everything that you need to copy. All right, and then we need one other thing, and this is an entry point. This is when your container gets run. What runs? What are you gonna run? Now, a lot of the times when you build your app, you'll do a build of an app. You'll build your app here. Let's do this. Build your app, and we'll do this with the Rust project that we're building in the Rust class. We'll build our app, and then you'll do it. Yeah, let's say you run make. Let's say your app builds by using make because it doesn't have cargo. Actually, in ours it will be cargo build release. Right? Awesome. All right. Now what you need is an entry point. So run your app. Okay, so we're just going to do something like this, where we're going to run whatever is built from this release, and hopefully it's called my app. We can set the outputs on cargo, and we can define this. Let's tackle that in a second. But this is the basics of a Docker file. This is like the very, very bare bones basics. And we're going to now actually take this and make our last app that we just wrote in Rust. And we're going to basically just do this with it. And actually build our own container. Before we do that, we're going to delete all this stuff. No. We'll just do the Rust one. I was going to make a container that wasn't our Rust one, but I feel like that's not really building a container. So let's actually just do our Rust one. So in the root directory of our Rust project, we're going to create a new Docker file. And then we're just going to do from Rust. I should have just started with it. Oh my goodness. I can't type. From a Rust. Okay. VS Code obviously has some good support for it. We're not going to pick our Rust version. We're going to just let it be latest. This is not great if you want a reproducible build. Each time you build this, it's going to pick the latest, which is going to be different. That's why it's not perfectly reproducible, but all right. So we'll get into that. What do we need to do? Well, Rust already has this image already has the full toolchain for compiling our app, so we don't need to worry about that. But we do need to get the code in there. So let's copy all of our source code into this container. That will be a good one. And then the next thing that we need to do is cargo build this. But we can't do this. This is dumb. We need to do run. Run is how you run a command. This is how you run it. And we want to build it for release because we're building a release container. Okay. Now, I don't know where cargo build release puts this object. Let's go figure that out. A lot of you were here for the Rust class anyways, so this will be a little Rust 102. This is still going. We're going to stop this because, my goodness, that's taken forever. Let's see what we have. Docker images. Look at that. So much better. Fantastic. Awesome. Okay. So, Docker PS. Boom. Done. All right. Are we in the right place? We are in the right place. Okay. So, if we do cargo build release, let's do help. we want to probably define what we want it to be called, how we build it with release. So we see that release allows us to do that. And we have an outdir. So we could leverage the outdir and where to put it. This is unstable, which is fantastic. Fantastic. Okay. So we can work with this, with the build for what we want to do. And there's a lot of other stuff that we'll get into. This is not the Rust thing. So we just basically want to control a little bit of where it gets put out to. But what we can also do is just do cargo, build, release, run it like this. You'll see it compile because it's going to compile everything for release. So even if you've compiled it for debug, again, this is talking about Rust. We'll do this again for Rust class. All right, cool. So we built it, but where is it? Where is it? Well, we can see that we have a target. In here, we have a debug and a release. In here, we have, it's called day 2. It's called day 2. That's what it's called. That's our app. And we can run it from here. Cool. So now we know where it is. Now, in this case, then, if we want, we can do what we did here with the command with target release day 2. Now we can rename it. We'll talk about it. We'll talk about it. So let's just do this right here with what we've done. What we've done here, and see how this. Oh, I use shift. And we'll just call this day 2. Done. Kind of like day 9, but not as entertaining. All right, so now we have this file. How do we actually make it a container? It's just a file. Good question. And that's docker build, period. This is going to build whatever Docker file it finds in this directory. Now you can specify a specific file if you didn't name it Docker file, but it just looks in the current directory for a file called Docker file. So if we do this, it will work. So it's pulling from Rust. So it's pulling that image that we set as our base image. It's pulling all the layers, and we can get into layers. Easy peasy. Pulling those down. Done. Now it's copying our code in. Cool. Now it's running cargo. Super awesome. Super awesome. And we built it. Now let's check it out. Docker images. Oh, this kind of sucks. We have Rust. It pulled Rust for us. That's cool. But why is there this none? Is this our image? Is this our image? That kind of sucks, doesn't it? It does. It absolutely does. So what we forgot to do here was build. But instead of just giving it this, let's give it a T, -T. For tag. And let's call this learning day 2. Yeah, we'll call it that. And we'll do it here. Now, cool thing is, Docker didn't have to rebuild anything. It just checked if anything had changed. None of these layers changed. So guess what? It didn't do anything. It just retagged it. Cool. Let's do Docker images now. Holy crap. We have a learning with it. This is a bad tag, but whatever. We have a learning day 2 tag. Cool. This is actually day 1. It was day 2 of Rust, day 1 of this. Got the days all confused. Okay. So now we have an image. Cool. We've created a Docker image, a container. All right, so let's run it. Docker PS will give you running containers. We can see that we have 2, but let's not worry about those. Those run because of my kind, but don't worry about those. So let's go with Docker run learning. We don't have a latest tag. We have a day 2 tag though. So let's do that one. Okay. What? What? We didn't provide it a port. How cool is that? That was our app. That's our Rust, right? If we do cargo run, error. The following requirements were not provided. Port. Check it out. That's our code running. How cool is that? How cool is that? In a container. All right. That was just the most quick and simple possible intro into a container. I left the music on, didn't I? I did leave the music on. My bad. Usually during the educational pieces, I don't leave the music on. We just have a conversation. All right. So there's so much more to building a good container that we can get into, and maybe we need to do a whole section on containers. This was planned to be a Kubernetes thing, but there was some of you that wanted to learn Kubernetes that didn't understand containers, and I'm starting to think that maybe we need to do them hand in hand. You have the skills in place now. Did everybody do this? Did everybody follow along? I actually meant to stop. I do this with the Rust. I want you to do this stuff with me. I want you to take whatever your application is, and I want you to build a crappy, terrible, horrible container for it while we're doing this. So you can ask questions, so you can figure it out, so you can fail at doing it while there's some experts sitting here. The goal is to get you to actually do it, because doing it is how you learn, how you cement it in as a skill, as it becomes second nature. Why did I know that copy was here or add or whatnot? It's because I've typed these things 100 times and know how to use them. You know, if we wanted to do a multi-stage build, I don't even need to look up a multi-stage build because I've done multi-stage builds so many times. Like, as a builder, and then, I can just go through and do these things. And so it's important to do. It's important to do. And I don't want this just to be a stagnant, refined thing. I want us to have problems. I want us to figure out the problems. If you have a Python app, guess what? Do from Python. I think Python probably has one. Yeah. And you probably want to pick the Python version that you want. Go do it. It doesn't need to be this Rust app that we built. Get dirty in the code. All right. So, questions, comments, concerns? Let's see, what time is it? 2:19. Do we start Kickstart? I think we start Kickstart, and then we'd be done. We kickstart Kickstart. We kickstart the Kickstart. We kickstart the Kickstart. Okay, so there's going to be an ad. When there's an ad, I'm gonna go get a drink, and then we're gonna start to do Kickstart. We're gonna get rid of this garbage. That's not what I meant. That is. All right, we're gonna open up WesTerm. We're gonna feel a little bit more hopeful about things. we're going to, grab Kickstart and do that. Unless if people have questions, ask questions now about the containers. Did that all make sense? Are you guys just speechless by how clear that was, or unclear? I'm gonna go with unclear. Probably more reasonable. Hey, look at that. We're up to 400 followers. Do you guys know that there is a 1,000 followers goal that we're doing? Well, thank you, Cypher. You guys teach me a lot too. I like doing this. I think we all learn stuff from it. Well, yeah. So I'm trying to have these two Rust and containers, and as soon as we do the Kubernetes and whatnot, we'll rotate topics. We're going to be doing some machine learning in the future. We're going to be doing that on stream as like our projects, and then we'll do some classes once we've learned some stuff on it, where we walk through the same things. But I really wanted to. I made this YouTube video. I made these YouTube videos, and I didn't like how sterile they were. I made these YouTube videos on like Rust, and I felt like they were just like really sterile class things, and like those are fine because like if you guys have a question on enums now that we've covered covered cargo, and you wanted to learn more about cargo, I think that this is a really great resource. So I don't hate these, and I think that they solve a really good purpose. But I also think that like there's a lack of the organic, like, oh crap, let's actually figure out how to debug this. And something comes up and whatnot. The more real organic feeling type of stuff. So anyways, that's what I'm trying to do some, instead of like, hey, here's a happy path. And I think again, this has some stuff, some value. It's valuable. I just want to make sure that we're doing the other side, which I feel it doesn't get done as much. You can go follow Let's Get Rusty. He does some really great videos, probably better than I'll ever make. There's other people that you can follow, but I wanted to do some stuff where we were very, very hands-on. Okay, anyways. Okay, let's get out of this. Don't need that anymore. We'll leave this up. Okay, so what I want to do is I want to configure Vim to open up with two different configs, two different plugin configurations, because we saw like when I'm doing the class. Actually, let's get into this after the break. We're gonna I can just press the button. We're ready. So I'm gonna press the button. I'm gonna go get some water. I'm gonna stand up and stretch. You guys hopefully do the same, and then I'll see you back, and we'll do Kickstart right as we get back. Let's just do. What is this? What is this? Accelerate. Okay. Be right back. Be right back. Ads. Okay. I'll be right back. Enjoy your 3 minutes of peace without me. All right. Let's see. Okay. We'll get some music for this. This is just bonus time. Let me update the title. All right, so I did not. All right, so basically what I'd like to do is I'd like to have two different configurations. And I know that you can start Vim, you can pass like the configuration you want. I don't know how to do that. I've never done that. I'm not a Vim expert. I am just learning. Okay, let's just... Ooh, can I get a tilde? Which one? There we go. All right. Let's look here. Let's see. Wait. Where is wait. Is it in Vim? Where is Vim stuff stored? Okay. Yeah. Okay. Let's I guess we should just delete this. Let's start with that. We're gonna clone the Kickstart. GitHub hub Kickstart in Vim. We're gonna clone this. We'll keep a copy. I said clone, but I meant fork. I meant we're gonna fork it. All right. I don't have any public. Wait, it's public, so my SSH keys should work anyways. It'll be fine. I need to set up SSH keys for my new non-sudo user. I'll just use my sudo user though. We'll just there we go. Done. Sweet goodness. All right. Now we have this. Kickstart targets only the latest stable and the latest nightly of NeoVim. If you're experiencing an issue, please make sure you have the latest version. Probably do. I'm on Arch, by the way. Did not do this. I just deleted it. It's fine. Probably. Yep, got this. Forked it. Cloned it. Start NeoVim. That's it. Done. We'll start NeoVim now. Don't we need to, because we've already done it, because we've already started Vim, don't we need to actually call lazy? I think we do. Let's do clean. How do I actually run clean? Maybe it doesn't have anything that it needs to do. What does sync tell us? Ah, there we go. That's what we needed. Error during completion. CC1P plus. Fatal error. No such file or completion. What? What? Uh-oh. Uh-oh. So, tree sitter failed. Why? I'm just trying again. Wait, did that fix it? Where's tree sitter in here? Did we just delete tree sitter? Is that what we did? That seems like, I don't know. I'm not entirely sure how, if this is working. Oh wait, is this an update on lazy? Is that what needs done? It says it's up to date already. Let's see, log. Maybe I shouldn't have clicked around for a little bit. Did I just clear up the error, or was this just, I've just stomped on the error now? All right. Well, we'll get out of it. Now, I feel like... Okay. I feel like this isn't updated. Like, this feels too much like my old setup. Right? This feels like too much of my old setup. How do I know that I'm actually using this? How do I actually know that I'm actually using this? Did I put it in the right place? Maybe I didn't. Let's actually check what this is. Actually, I think honestly I'm not in the right spot. I think I think I'm just in the wrong spot, because I feel like it should be here. And that's not where I was. Why do I have this in a different place? This is the right place. By the way, this is the right place. I mean, I'm not in the right place. It is why do I even have it here? Okay, I just messed with myself. Okay. Let's just delete that. I don't know why I have this directory at all. We're just going to take this command line, which is going to be nice. Let's rm rf config NVIM. We're going to remove that. We're going to clone this, but not this. We want to clone our branch. Our branch. There we go. Now, if we cd into config, NVIM, and then do vim here. Ah, there we go. There we go. We got the new one. That's what we wanted. All right. Cool. Nice. All right. Nice. You know what I probably should have done? There were some things that I did like all my key combos. I probably shouldn't have just stomped on those. I did. There's no going back. There's no going back. That's okay. Like, yeah, my space FF does not work anymore. It doesn't work anymore. Okay, that's okay though. We're good. This is kind of weird. Why does it highlight the whole line that I'm on? Now, I do like this. This is one thing that I do like, where there's like a buffer between the top and the bottom. That's cool. I actually really like that. Okay. Okay, look, this is looking pretty good. Okay. So first things first, one thing that I actually want to do is I do want to make this mine. And one thing that I did that I didn't love last time was I made it all one file. Like I just left it this whole big file, and that was painful. So this time I actually want to logically break this out. And what I'd like to do, I think how I was thinking about this, was I've been looking at how some other people do it, and how I think I want to do it is basically some of the big components I want to configure in their own file. I want to configure hotkeys in its own file. So if I want to go change my key combos, that's in a file. I don't have to search through I'd like it to be like, but this is hard because it's like key combos for what? So we're going to have to think about it. Do we have a nerd font installed? I believe we do. We'll find out. I expect that to break things. I don't like relative line numbers. Like if I wanted to go to line 99, I just do 99 here. So like I feel like having relative line numbers doesn't help with that. I don't know. It confused me. Change the color theme a little. I don't think I changed the color theme. I don't know, Scott. That's a good question. We'll find out, right? We'll find out. All right, let's at least do the languages. Languages. We need some LSPs here. Wait. Where's... I thought he had a list. Where's the list? Maybe I'm reading too quick or not reading enough. Probably not reading enough. I thought we had like a Rust. Ah, here. This is what I wanted. The local servers. This is what I was looking for. I think that we use all those. Let's check this out. Help LSP config all. This is cool. This is cool. Has view. So we do use view. So we could do view ls. We'll give that a try. Got Lua already going. Mason. Okay. But yeah, I don't want to do too much here. So this is all setting up here. Should this go in its language setup? Should we have a separate file for the language? I'm thinking. I was thinking we'd put like lazy, but I feel like we need to actually break it out more. Like we can break lazy out into its own thing, but like I feel like our configuration of languages are pretty simple at this point. Yeah, so okay. All right, we're getting there though. This is like maybe a start. No space Vim. What do you mean space Vim? I don't know what it is, that is. Look, I'm really new to Vim. I'm like a Vim part-timer since like February. Oh. So I'm doing this actually for a very specific reason. I'm doing this for a very specific. I'm trying to learn Vim, and so I think Kickstart's like a really cool way to like actually learn. It's almost like the Arch Linux of Vim, NeoVim distributions. Like it's kind of like build your own a little bit. So this gives me an excuse to actually learn the insides, like to actually learn it a little. Instead of just like using, you know, like there's like NV chat or stuff like that. And this space Vim feels like, or looks like it might be similar. Actually, having the file open on, I'm not doing that because I'm really using Fuzzy Find and liking it. Sometimes I wish I had this though. Sometimes I wish that I had this. Yeah. Absolutely. That's why I do what I do. All right, cool. So we have a couple things that we wanted to change on this. Like one, when we start, we really want fuzzy find. I think fuzzy find is my favorite way of getting around, and we really want fuzzy find to go. So I think maybe the first thing that we do is our key bindings. But it is getting towards 3 p.m. and I have stuff to do with my kids. So yes, I guess we really don't have time to do this. We got the new one. We're forced to use it now. So if I want fuzzy find, I'm going to have to do the key bindings next stream. Because that's all I have now. This is all I have. And I can't even get fuzzy find because it doesn't exist as a key binding. So we'll do that very next stream because, well, next stream is the news. But very next stream that's not in the news, we will because... Can't type. Yep. Okay, I got to now. This is good. This is good. All right, let's find somebody to raid. I do have to go, unfortunately. Fuzzy find isn't Space F. Fuzzy find is not Space F. I was trying. Space FF? It is not. That's what I Telescope is a fuzzy finder that comes with a lot of different things. It can be fuzzy find. It's not Space FF. I'm telling you. I'm telling you it's not Space FF. Maybe it's Space SF. I'm hitting Space FF, okay? I know how to... Hey, that's been my go-to. I just... Oh. Anyways. There's the buffers. Okay. I think either he changed the... Yeah. Okay. It's Space SF. Got it. I like FF better. I'm going to change that back to FF. I don't know if I changed it from what he had last or if he changed it to S. It looks like everything's S now instead of F. I feel like F is more easier. Did he change the start of all of these to S? Weren't these all F originally? That seems like a weird thing to change. I mean, maybe there's a reason. Let me try this. Now that I know, I feel like FF is easier though, honestly. I wonder if there was a reason. Like, so making this type of change makes me think that there was a reason to change this. I don't know what that is. Huh. If anybody knows why he changed this, I'd be really interested because, like, maybe there's a really good reason and I just don't understand it. It seems like something that would be weird to change, though. You know, it's like one of those breaking changes where you're like, no, there was a reason. Yes, if I knew how to do multi-line. You guys always tell me how to do multi-line and it never works for me. Except that one time. It worked for me that one time. And then I've never been able to repeat it. I've literally never been able to repeat it. Okay, well, we're gonna go with F for right now, but I'm interested in finding out why he had changed it. All right, let's find somebody to rate. I do have to get going. I do unfortunately have to get going. We'll find out. Oh, look at that, an echo. Fantastic. Oh, look at that, an echo. All right, I stopped that. Let's find somebody to raid. Who do we want to raid? Let's see. There is so many things. Let's see. Do we have Rust? The Alt F4 stream, I guess, is tagged Rust. I don't think he's actually doing Rust. He's doing birthday DevOps. Interesting. Let's see. A recommend for me, viewers. Viewers low to high. Let's see if there's somebody that doesn't have the viewers they deserve that is doing something interesting, or possibly doing something interesting. Let's see. Working on LAPD. Don't know what that is. That's not in English. I dumped you guys into an non-English stream once. That was embarrassing. I do check for that now. That guy's learning Python. Why are there so many VTubers now? That's a lot. Is it like a really common practice? Maybe it is. Maybe I'm just like a really good AI VTuber. Built this AI. Why is finding somebody to raid so difficult? I want to raid somebody with fewer viewers. Okay, there we go. Scott B. Wait. Okay, we got two. Rust, but German. We're not going to do German. Let's do the other one then. Let's do that one. If you guys have one that's going, let's do that. Cool. Super nice and pen tester. We could all learn something. Thank you for the raid. I have not watched their channel. I plan to see some more. All right, so thank you everybody for joining. I hope that this was fun, maybe a little educational, maybe a little both. Maybe it shows you what not to do. Maybe it shows you how to not be a streamer. That's something we can learn. Anyways, thank you so much for joining me. Go have fun. Give this guy a great time, and yeah. See you guys later. Thanks for joining. Bye.